running riot.
Heat, sir, man.
Hello. It is time. I did a little bit yesterday. Not too much. I don't think it was too much. But I can definitely say the fun part I still have not done. So I got, the settings are, kind of here. Not really. It's just an ID that I can give and then, enabled or not. I think I meant for this to be -1 though. Yeah, this should be allowed to be -1, which is effectively disabled. Okay. Just that if I click add and I click populate, it wouldn't do anything until I actually set it. And then I can always turn it on and off with that switch as well. So I guess I actually need to do that check too. If this is not enabled, or ID, so I don't need to parentheses there like that, or ID is -1. Okay. Alright, let me walk you through where I'm at. So, populate region just starts like normal. Then we have these settings, which I guess I should probably look at that. So settings is literally just this. It's just a resource that keeps an array. The reason for that is so I can share a collection of settings among regions. If I were to just put the settings as the array itself on the region, I'd have to manually go through and add all of them, and then the order will also matter, but that'll be clear later. The order is essentially which one is gonna try to place first, so who has priority to place. So if I have trees and bushes, I probably want the trees to try to place first, rather than bushes. Because if I were to place a bush, I can't put a tree on top of the same spot. But I haven't quite decided yet if I want to allow... That might be a setting. Because I think I would like to allow bushes to spawn on top of trees. Because I'm not going to have trees be like that thick. And it is reasonable for a bush to grow right next to a tree. Pretty much on top of a tree. Like engulfing a tree at the base. So that's why this resource is just literally a list and nothing else. Here's the real settings. So you give the ID of the asset you want to place. I just have the enabled. I mean, you can see it all here. And I have a density. And I don't have it open right now. But I guess let me open it. Right. The graph is gone, but I did at least write it down before I got rid of it, and I could remember it anyway. It's like the cosine, negative cosine x pi over some value plus 1 divided by 2, and then tan h that. Oh, and divided by pi, not divided by 2. Divided by pi. Pi, yeah, x times pi over some value plus 1, negative cosine over pi tan h. Okay. And then of course x has to be clamped between, or nearest has to be clamped between 0 and s. Okay. So far that's just what density is going to be. I will map it, so I think density would be like the inverse of this, like 10 over the density or something. But I'll figure that out. I'll do some multiplication. Do it. And then this is just a true or false if a random number is less than or equal to this value. So the higher this value, the more likely it's going to be, because random's going to... Yeah. Okay. So now the fun bit, populate instances, or just populate instance. I guess I'll walk through this. So what we do, I have some bookkeeping stuff here. So I have the tracking, which is going to track every instance that I've placed, every important one that I care about. And this one's going to be a dictionary of map instance ID to a vertex array, which is going to be stored as a packed in32 array. These will be mapping a vertex, just a vector 2 I, to an instance ID and whether or not it was used. That'll be important later. This is for raycast testing on the triangle mesh. I feel like it keeps getting darker because it is getting darker. Keep turning this up. Okay. Then I just have a bounding box, so I will check every vertex in this bounding box. Vertex loop, just normal stuff. If it's if our position is on the triangle mesh, we keep going. Or if it's not on the triangle mesh, we would skip that vertex. Then so it is on the triangle mesh, so then I check that the terrain, this is a position on the terrain. This could be something like a hole, or perhaps it's not in the region. Let me check that that also checks for that. Oh yeah, I think this returns, yeah, it returns this value if it's outside the terrain, so that as well, yeah. And then on that position, I run my placement function for every instance that I have that I may want to place. And it's going to modify these two things. It's going to modify tracking and it's going to modify output. Once I'm done with everything, I clear these two just because there may be a memory problem. So, and this copy step here is going to start consuming a lot of memory for very big meshes. So I'm just trying to optimistically trying to claim it back as early as possible. It may not be necessary. I don't know exactly how GDScript works. It might see that these are no longer used after this loop ends, so it may just deliberately deliberately clear them on the spot. But I just want to be sure, because I kind of doubt that it does that. I actually doubt it. Anyway, then I guess I didn't mention what output is. So output is a dictionary. I think I did. It's an instance ID to a vertex array. So it's just every vertex, every instance, and then every vertex that I want that instance to appear on. Okay, so then I will loop through that. You'll see I grab the keys up front because I'm going to be erasing it as I go. And I don't think the for in works if I'm erasing. So I can't use the iterator. I have to iterate over. This should be a copy. When I grab the keys, there should be a copy. Yeah, it wouldn't make sense to be allowed to modify this list. So I grab all the vertices. I grab the size. I prepare my transforms and colors. And I'm tracking two different variables here, just so I don't have to add or multiply or divide 1 by 2 or whatever every time. I can just add 1 and add 2 and then that's it. So I grab the two coordinates here. I do a small variation off of that vertex. You'll see I don't go all the way. So I don't, I restrict the range. So this would be 0 to 1. I restrict that to 0 to 0.7. And then I subtract 0.35. So the instance that I place can vary by 35 centimeters to each vertex. And that's basically a box that it floats around in. Kind of I don't exactly know how far Minecraft allows variation, but I know that if you place grass on blocks, they have their seed tells them how far off the center of that box to go. And they can overhang a little bit, but not very much. I'm kind of emulating that. And then I grab the height from the terrain. Then I have a height variation. I want to add that as a setting so I can have a mesh move up and down a little bit. I also need to do things like rotation. So I'll just rotation, variation, scale variation. I guess this would be a to-do. My idea for the color variation is I actually provide a list of colors that I want it to pick from. And I assign a weight to those colors. That way I can specifically pick the color that I want to choose, that I want to be a possibility. And I guess I might be able to assign a little bit of variation of those. The issue with colors is there's no set way to vary a color. For foliage, typically you want to turn up. Do like green to red, vary in that region. For a rock, you might want to just make it darker or brighter. You don't really want to do color variation. Or sometimes you want a rock just to be super red or sandy or gray. There's no real way to pick one color and then say, vary these channels. So I think just a list of colors that are options. Color variation, list of weighted options. Okay, and then I assign those and I increment. So you see I'm using K here, which I'm going up by 1 every time, and I'm using I for this, because I go up by 2 every time. And as I said, for each instance that I produce transforms and colors for, I will erase it because it could be consuming a lot of memory. So I want to free that up as I go because I'm just using more memory here and then I'm never going to use it again, so I may as well erase it. And then I save that to the data set, and then I call add instances. Probability function's done. The main loop here is done, except for some settings with variation, particularly transforms and color. And now here, populate instance. This is going to have a lot of settings. For now, the only setting that I care about is density. And I'm going to do the strategy where I have my tracking array. In fact, I also just realized with a tracking array, once I reach here, oh, actually I just noticed. So what I'm really doing is I'm going across the x-axis and then I'm going across the y-axis. It doesn't really matter. I just have to, I guess, be aware of that. Let me change this around. I actually want to do the y-axis first and the x-axis. I think that'll be a lot easier. By y, I mean z-axis. It'll be easier for me to wrap my head around. Instead of going vertical in columns, I want to go horizontal in rows. So I'm going to do that. I'm going to change this around. Pause. This would be Z. Z. And this one is Y. X. It's VX. VX plus 1. And right here, whenever I drop a row, there was one issue that I realized. Because I'm not going in a perfect box, I could have a triangle like this and then a triangle like this. All right, I guess I'll just draw it. It's way easier to show. I can just discard that one, I guess. Okay, let's zoom in. So let's just assume for a second that I have that I have boxes like this. Or try that again. So let's say this is one triangle, and well, actually, that would be one triangle, and this would be another triangle. Just assume for a second that these are two triangles, even though they don't really look like triangles. I'll make them look like triangles. So if I'm going across, and I'm filling them in like this, not like that. You might even be able to see it already just with the top triangle alone. But once I get here, what I said was I would remember the closest point to this vertex. So when I come here, I treat this as my reference circle, which is incorrect. I should actually treat this one as my reference point. So how do I know? I guess one way I can do it is I can, when I reach this first one down here, let me just color it back in so it's easier to see what's happening. So my first thought is probably when I get here, I just go up to this point and I compute its closest neighbor. And I just have to do a spiral pattern. I have to do a full search at that point because I don't remember it. Which, if that's what I have to do, then so be it. But one thing I could do is I could remember the closest point to every vertex, every cell per row. So I remember the entire row. So wherever I end up next, I can just look up, straight up, and I know the closest neighbor to here, and I can go from there. And that should always be the closest one, because if I'm going left to right and then top down, the first hit above me should be, and they'd all be in the same row, so I kind of get that for free. I know which row it is. I just have to scan through every column until I find, or I guess I would look at this column, and if I don't find it, like let's say that this is not in triangle, then I go left and right, checking right first. So I check right, and then I check left, and then check right, and then I check left, check right, check left. Because I know which way I'm going to be going that way. And see until I find a cell that exists. So maybe to demonstrate what I mean a little bit better, let's say the triangle looks like this, is way over here. I would be scanning for the points up here first. Well, this point doesn't exist, so I go right, doesn't exist. I go left, doesn't exist. Right, doesn't exist. left, right. I'm out of right. Doesn't exist. Left. Doesn't exist. Right. Doesn't exist. And then finally I hit one. Is there perhaps an ideal way to do this? Perhaps the ideal way to do this would be to go up and just keep... I guess here's the issue, right? The stuff above me could look like literally anything. It could look like this. Right. This could be the mesh. Perhaps I could alleviate this by saying the mesh must be continuous. I can't have gaps like this, but I kind of don't like that. I would like to be able to have gaps. I like to be able to have triangles just sitting off in space without being attached to any other. I like to have islands. I like the region to support islands. So the first idea, you know, would be, okay, well, let's only look at the ones that we know exist. So we go through each one of these and we figure out which one's closest to us. That could work. What you would do is you would essentially just check each one, compare its distance to you, save that best distance, get closer, save it, get closer, save it, get closer, save it, get closer, save it. We'd be closer still. This point's still closer than that point, so we would save this one. And as soon as we get further away from us, then we know, okay, well, we were at the best one. We found the best one. We won't be able to find anything better. And as long as I'm only saving it per rows, so I couldn't have something... I would not have something like this. Well, I could have something like this, but then I would only be checking... Ah, see? Here's a problem now. Now I see the problem. I would only check those, and I would actually miss the fact that the closest one here is here. This point is definitely closer than this point. I think so, at least. Visually, it looks like it. Okay, so that's a problem. I cannot just track the last row. I have to track... I guess what I would do is I would track the last bottom row. There's definitely a way I can do this where I actually save both of these. Essentially, I would key it by column. So I key the closest, I key every column. So as I go down, I'm remembering these. This could actually be in the tracking, because the idea with the tracking is that if there's ever a cell that I don't end up checking during a full sweep, I should be able to delete that, because I should never be closer to it again. Perhaps there is a problem to that, though. I did just imagine a problem. So let me reset. Let me imagine that I have a shape. I'll just draw boxes, I won't draw triangles. I have a shape like this. Okay. And I happen to have a tree sitting right here. So as I go across, I would fill in these 2 points, and I would say, okay, going by my tracking logic, I did not ping any of these as being the closest tree. Actually, then this would have to be a tree. Both of these cells would use this tree as their closest tree. So then this tree would actually not get used. And by my logic, what I said is I would forget that tree. I'd forget it. These would freeze, but then I get to this point. And obviously, there is a tree right here that should be influencing this cell, especially this cell. it would really influence this cell. But because I had forgotten it, because I didn't use it on this row, it's like it's not there anymore. So I suppose what I could do instead is I could track This is difficult. Is there a rule I can add that would allow me to keep that tree? Here's an idea. Okay, first idea. Do I really need to do this? I think I probably do. I think I genuinely need to do this. But here's an idea. I keep it keyed by column, as I said before, where I always remember the last row, but the last row as in the last closest thing for each column. So, let me draw slightly larger islands. And I guess I'll do this. So as I go through, I feel like I need a better color. Like a slightly lighter gray. That's, how was that even close to the color I just picked? It's not, because it wasn't. Okay. So this will be my unfrozen color. This will be my frozen color. So the idea is, because I know that I'm going left to right and down, I could remember tracking could literally just be the closest, the distance to the closest tree for each column. And if I find a column that has a closer tree, I overwrite that column's closest tree. So theory is that if I'm going left to right and the above me is always frozen, a tree here will always be closer to anything to the right than a tree here, always. You could definitely prove that geometrically. This tree is always closer to every cell on its row than this cell ever could be. Forever, to infinity. So basically, I guess I could just key it by column. In fact, I could really just key every tree, every time I place a tree to a column. So if I place a tree on this column, it overwrites this one. Let me go ahead and use the freezing stuff. So really, I just remember the closest tree on each column. Right? So that would actually remember all of these trees. And I guess then in that case, is it possible that I can say, if I have a column that is not read from, can I guarantee, is there any time that I can guarantee I won't be using it? I think I can guarantee I won't be using it after I pass it. If I was working on vertexes with column values greater than this one, and I never read this one, then here's the thing. Every point is going to be the only possible points I can read after that point only possible points I can read after that point would be these ones, right? I could only read these ones from this point on. Assume that one doesn't exist. So after I've passed this column, if I don't use it, if I haven't used it anywhere here, that doesn't actually prove that I can use it, because right here it probably would be closer. It's definitely closer to this one than this one, so I actually couldn't forget it. Because there's still, like, there could still be a big void over here where there's just nothing. I think there's a way I could construct a circle around this point to say that if I am so far away that there's another point in this radius around it, then I know for a fact I will always be picking that point over this one. I guess that is an optimization that is a pruning method. If I can start with a circle here and grow it downward and find a point inside of this area, inside this circle, I guess it doesn't really, maybe it doesn't, there's definitely a certain way to grow this. Maybe in like a cone, some kind of cone shape. Because like I said, I can definitely, okay, so I can absolutely make the case that a tree here will always be closer to everything underneath it than this tree. So I can absolutely make that case. And I can make that all the way down. So I know for a fact that I can at least order it, I can at least key it by column. So if I get a tree with a higher row, but in the same column, I can just overwrite that one and forget this tree. But there might be like a cone that extends down. I'm hesitant to say that it might even just be 45 degrees, a 45-degree cone. Or a 90-degree cone. For some reason, I'm thinking of like those space-time diagrams of like a black hole. Is a point here? Not necessarily. I think there's a distance somewhere over here where this point is still closer than this point. So I can't make that argument. I could definitely make the case that this one will be better over here always than this one. This one would be better over here always than this one. So perhaps what I can say is have a cone where if both of these trees exist, I can prune that one. If these trees exist, I could prune these ones for sure. Interesting pattern emerging here. If I place these, okay. Okay, I think I've got it. If I get any trees down here, I could definitely, okay, if I get any tree over here and any tree over here, I can remove this one. if I get... There's a 45-degree angle here. If I get trees from this point, from at least this far down, anywhere on this column, I can drop this one. I could also drop these. If I get any tree over here, I could drop any tree in this box. Because the closest one that could happen would be this point. Let me go ahead and draw this black. I could check this point, but both of these trees will always be closer than that one. Now, here's why the 45-degree matters. Because this breaks the case. This tree is closer than this tree to this point. You can just count out 1, 2, 3 in between, 1, 2, 3, but then there's an extra vertical 1 happening. So essentially, it's literally like building a tree, right? So a tree from anywhere on these 2 points, anywhere down the column, can drop everything above it, everything in this area above it. I've geometrically constructed that. That's definitely true. How do I implement that in code? As a pruning method. I think it's computationally expensive. Memory might literally be cheaper than computing that. And I feel like the chances of that happening are probably pretty low until you get something really dense. Like, unless I'm placing trees, like with this kind of density, that extra bit probably doesn't really matter. And even at that point, remembering it by column might just be the right way to go. Just remember by column. Then here's a thought. What if it's like a large area? Yeah, what if I have an area like this? Right. And I'm placing trees like this. They're kind of spread out. I guess it's probably kind of hard to really show it without the area being like very, very wide. Maybe it would be a good idea to compute that, because look at every one of these trees. I have quite a lot of trees. But I think just observing this, I absolutely don't need to remove this tree anymore. These two trees at this distance should cover that. There is no way anymore for this tree to be closer than either one of these two. I guess one way to look at this is if I were to draw a circle around these points. I'm just going to like try to visualize this. So you can see where the intersection is. Alright, I guess I would probably start with this tree actually. Let me start over here. So if I were to draw a radius out from this one, you can see that this tree on the bottom left, I hit. I hit that tree before I reach the next empty row. So I think what that means is, at least to the left of this point, there's no possible way, to at least to the left and down, there's never going to be a tree, there's never going to be a cell closer to this point, closer to this one up here, than that one. So then, I think at that point I would draw another circle, and you can see this one, now I've hit that one. So I can say, for a fact, that excluding pretty much these cells right here, every other cell is going to be closer to this one than this one. So that's probably one way I could prune it. I can use that column tool, or the fact that I have it indexed by columns, to check. Anytime I go through a row and I don't use one, I check the ones that I didn't use, and I do this calculation to see if this circle encompasses, to the left and the right of this cell, at least one tree, and also does not encompass any unknown cells. And if that's true, then I know that the cell to the left and the cell to the right that I hit will always be closer to anything that I will ever place. So then that allows me to prune this tree away. That's one possibility. I think that actually that's probably the solution, isn't it? I would just start with a circle and I would progressively grow it, looking down only. I guess I can also look left and right, but I think just only looking down is probably the right way to go. And just keep growing it, looking for, I guess what I could, here's an idea. So back to like a graph idea. Cells could also remember a left and right closest tree. If a cell right here ever gets a left and right tree that are closer than the unknown area, then I can drop that cell. That cell can go away. Because it knows that these two trees, the bottom left and the bottom right, are going to be closer. And I still key it by column, so I would just, this one would get dropped if I ever place a tree underneath it. So I place one here, this one just guaranteed we can drop that one. Don't even need to check. And so this one, and I actually know that because this tree would point to this one. This cell points here and says, yeah, this was my closest tree at the time that I placed. This cell would say, it would actually point to this one, really. This one would probably also point to that one. This one would probably get pruned because this one would point to here, this one would point to here. That would just get pruned immediately because we placed 2 trees that pointed to this one, so we were able to map those. But then, so if that happens, that's kind of like for free. We just happened upon it. We didn't have to check it. We were already checking it, so we could drop it. So that one would get dropped. Let's just draw one more line. I'll draw 2 more lines so I can like prune this. Let's say that along this line that I just placed, I never use this tree. So I would say, all right, let's go back to this tree and let's figure out what's going on with it. We know that it already has a closest left neighbor. Can I undo that? We already know how it has a closest left neighbor, so we don't even check that. We're just going to look for the closest right neighbor. So we start filling in our circle, going out until we encompass something to the right. So this one would encompass that one. And I would say, all right, well, we encompassed it and we didn't reach the unknown area yet, so I know right away this tree can be pruned. We don't need to remember that tree anymore. This tree, the same effect. It already would have a left neighbor, so I wouldn't even look for that. I don't look for the right neighbor. We'd grow. Still not find anything. Still not find anything. Still not find anything. And I guess this one, I guess technically would reach its end and not be able to add another layer. So let's just pretend that we can just say, all right, well, we probably don't find one. So and there's probably a smart way to check that radius. Really, I would only have to look. I would only have to look in kind of this pattern, I think. Actually, yeah, I guess I would only have to look in this pattern. But I would hit this one, and I would know for a fact that after I hit that one, I can drop this one. Maybe the existence of these two trees actually implies that this one shouldn't exist. Because as I said before, these would actually clear this whole area. But only if the gap between them is shorter than this distance, I guess doubled, right? So half of this gap, so this is 1, 2, 3, 4, 5, 6, 7. This is 4, so we know for a fact that this one should get cleared. Any oh yeah, I guess that's actually it, isn't it? I scan across in pairs. So I go across looking at these, and because it's ordered by column, I would actually just be going across looking like this. I'd say, all right, I have one here. Actually, that wouldn't really work, because if it is by column, I have to remember that. Okay, so the scanning part doesn't work. It's probably better to just use that used and unused flag, so I can like get a short list and say, all right, this one was unused, so we can go straight to it, and we can look at its column neighbors, essentially. And I guess when I said out radially, because I'm only keying it by column, I only have to check these columns. I would do 1, 2, 3, 4, 5, 6, and since I know this one's already connected, I'd have to keep that memory somewhere, but since I know this one's already connected, I wouldn't even look that way. I want to look to the right and see if I can find a column that is higher up than its distance to it is smaller than the distance down. So when I said radially, that's like the diagram of it, but since I have everything keyed by column, I have very few cells to check. I cover a large area very quickly. I could almost keep the keys sorted too. I could have sorted keys. If I keep a sorted list, is that right? Are insertions to a sorted list faster? Actually, it is, isn't it? Faster than an unsorted hash map. Right, it must be, right? Insertion in map has less time complexity. And I'm in a hash table or a sorted list. So this is what I would be looking for. Hash tables are known to be O1, while sorted vector O log in. Notation gives you the access time for n going to the infinite. You know your data will keep growing. Complexity notation gives you some hint on the algorithm to choose. For a few entries, bubble sort. What? Bubble sort. And log in. Faster to find an item. Because finding is the same as inserting. We know that your data will keep a rather low length, having only a few entries in your array or hash table. You must go with your watch and measure. Tough. I'm going to have a big list. I'm probably going to have a really large list. Or I guess rather the indexes can be very large. But I think it is going to be a short list, isn't it? Hashing can be slow. It's constant time, but it can be slow. Inserting can cause a rehash. I happen to have made a dictionary before in C, and rehashes can be really slow. When you grow your size, you have to... when you grow too far, you have to rehash the whole table, which can be a very slow operation, especially for large elements. Keeping a sorted list. You know what? A hash table is probably going to be faster. I think a hash table is actually going to be faster all the time. Because I need to remove elements too. For an array, that can be expensive. Even when I know the index. I have to add, remove, and find. I need to do all three of those things. I also have the unique requirement, which this can be served by either an array or... Oh. No, I just had an idea. So here's an issue with the array. I'd have to keep two arrays. I'd have to keep an array that is as large as the longest row I've ever parsed. I guess essentially as large as the bounding box. One dimension of the bounding box. So my bounding box is 10,000 vertices. I need to create a 10,000 length array. And that would be like a pigeonhole array. And then I would need a second array. So when I add to that array, I can just say, all right, I know exactly what I'm adding because I have my column. I key things by column. So I just overwrite that column in the array. But then I need to have a second array that's an index array that stores entries I've added. So when I'm sorting, when I'm finding, when I'm pruning, because I know that I have again with the pruning part, I have an index array, so I know which ones I could prune. So I go and I check each of those to see if they were unused. Then I might want to test to see if I can remove them. And essentially at this point, I'm kind of describing a more complex hash map because I have a key set and I have a value set. That's exactly how dictionaries work. You have a key set and a value set. So I may as well be using a dictionary in that case, right? The one that I wrote, it was template type. And it did use essentially a key vector and a value vector. So that value vector would grow. I could grow it and I could shrink it like an array. And I would just keep track of the indexes. And I would use a hash to, when I'm given a key, I hash it to get where its index should be, and then I would look there in my array, and I can't remember exactly how I think I did it, but I think I also used a linked list. So if it already had a value, but the keys were definitely different keys, I'd have to store it there. I still have to store in the same spot, so I'd use like a very short. I think I would go like 3. I think like 3 or something. There's a way you can make a dictionary where your value set has a maximum size per each bucket. The only problem with that is it gets memory intensive if you have too many collisions. So if you allot, I mean, it's also just generally memory intensive. It's like building bookshelves. But for every row, for every key, you have to have like 4 bookshelves. And if you fill up all 4 and you haven't used any other ones, you have to just keep growing back anyway. Hey, Danon. Ban all micro spamming. I thought I cleared chat. Does it just not disappear? I don't understand. Does it not clear my... Wait, does it not clear my own messages when I clear? I guess it doesn't. I was testing something. Okay, so I'm gonna use a hash map. And I think I've hit on a winner here. Each one of these columns can remember this is the tracking vector, tracking dictionary, keyed by column. Each column can remember if it was used. A rash map? No. But if I key it by column, I can remember a left and a right closest node. And then I can remember if it was... In fact, I don't have to remember a left or a right. No, I probably do, because it'll get to a point where, like for instance, I'm reading this row. And this is the layout. These 2 trees would key back to this one. So this one would have a left and right leaf, I guess. But I can't prune it yet because this cell is definitely, or sorry, this cell, I think this one counts too. Yeah, these cells are all certainly closer to this tree than either one of these, the left and right. So I couldn't prune it right away, but I will be able to prune it once I am far enough down. So I think this cell is closer. This one's closer to that one, I think. This cell. And this cell. Actually, I think this one's equally distant to both of those. So this one would actually not do that. This one would read that one as a close cell. So these 2 could still be closer to this one. So I definitely make sure that I'm only checking... I mean, like I said, its left and right piece, we have to be further down than its most distant one, I guess, is across. So like in this case, this cell is definitely still closer to that one. This one I'm not sure. Yeah, this one's actually definitely still closer to that one. This one... I think this one's closer to that one still. It's 2 diagonally, and this one's... I guess also technically 2 diagonally, but then an additional up. So yeah, once we get here, then I think for sure this one gets pruned out, because I think at this point, this one's probably closer to this location than that one is. I guess I can draw the circle to see it. Yeah, it definitely is, because I just encompassed that point, and yeah. Though this one may still stay, because I think if I'm going by the top left corner, actually I guess I should go by the center. This one fully engulfs that one's center. And where am I at? Here? Nope. Whoops. Yeah, so I think technically this one is better for this cell at this point still. Oh, but this cell would actually be served by... That cell actually gets served by this one. By this one. I guess, like I said, left and right. How do I do this? Would I look at these nodes and see if they collect, if these two... I said there was a construction that I could make at a certain point. Like using this 45-degree rule. There's this shape that this makes. Everything in these nodes could be closer to this one. But then I think because I reach the point where the only... I guess I claim this one is served because we're still in the gray area and we reach this column. So that one will be served there. The left side is always going to be closer to this point. Yeah. From here on, I would know after searching here, since I'm outside of it, since I'm still inside the gray area, this node, this tree will always serve everything in this entire region. And also technically this side too. It technically better serves this point as well. Then this way, I think because I am not in the gray area by the time I reach this column, I think this means that there are technically some points that are better served by this one than here. But I guess the check that I have to do is which one of those points is it, right? This is hard to spot. Cutting off ASMR is being really hard. I'm having withdrawal effects. God, that wasn't drugs. How did I construct this? I think I did it by the 45-degree rule, right? This is a bit of a strange rule now. Oh, I think what I said, what I could prove, was that the... Here's the thing, I actually don't have this. I was going to say the distance between these 2 points, if half of that is shorter... Oh, you know what? I think it does. I think I've proven it. So, as I go diagonally down, if I hit unknown territory before, or I guess even at the same time as this point, I guess what I do is I check here, am I gray, am I not? And then I check, is there a tree here? So I do this. I say, all right, I'm not in the gray area, so this one must still be a possibility. Is there... Is there a point? Is either one of these points closer to this one than this one? Let me see if I can construct that visually. Because I think it should be. Ah, okay. So this one is actually going to be closer to here than here. But I guess it's a bit uncertain, isn't it? Maybe it would actually be this point. Is this the point that's closer than the other one? Closer to this than that one? It is. It's this one. Yep. So I've proven it graphically. If we're looking at the center of each cell, this circle encompasses this center, but it actually does not encompass the center of either one of these two. So it is the case that I draw this diagonal line that way. But any cell from here and back definitely is going to encompass this one before that one. I've already proven that. I can prove it again. And it's a bit of a bad proof because I kind of just set it up a little haphazardly. This isn't like conclusive. But I think the reasoning stands. Yeah. So you can see I've encompassed this one and that one. Which means I guess at this point either one really works. I'm definitely certain that one of these two is closer. Which is this one. This one should definitely be closer. Is there like a line tool? If I go from... I guess center to center, same as left. That's that. So this says a length of exactly 5 pixels, which is interesting. And then here is also exactly 5 pixels. So actually, this is equally distant to both of these. And because that still means that this one is going to serve everything in this zone. From this same cell to the left, this one will always be closer. And this is the one cell that is actually closer to that one, 5.7. Then, oh wait, this one's closer. Interesting. Oh yeah, I think I said that it would be... What did I say? Would it be this one? 5.4, right. So this is the cell. Did I model that correctly? Maybe I didn't model that right. Or maybe I just misremember which one of these it encompassed first. I drew that wrong. Yeah, okay, but I mean I can diagram it. And I know still from this current construction that this one can't be pruned yet. And maybe it'll be more obvious when I draw this circle. Or I guess what I said was I would draw this pattern, and I hit the unknown before I checked this tree, so I can't prune this one yet. Okay, I think I've geometrically proven it visually. All I need to do is I need to keep a map of the dictionary of columns, and I remember a left closest tree, and I have to remember a right closest tree, but I don't have to write both at the same time. If I were to do this in the because as I go, I'm only going to pick one tree at a time as I write it. But at the very least, once I've placed one tree, every tree will either have a right or a left closest tree from that point on. And when I set the left closest tree, I would go to this tree and I would actually update itself to say this one's left closest is now this one. The reason I do that is just so I can check the unused one and quickly detect which tree serves could serve its left needs. And if I were to place one here, same thing would happen. This tree would write that as being its right closest tree, so I should go to this tree and say its left closest is now this one. And actually, in this construction, this one would get both. This one would say, here's my closest tree, it's to my right. So this one would read its left, right its left. This one would read this one as its left tree, so this one would write the right as this one. So then at that point, this one's like really primed to be pruned, I guess. We could quickly check, all right, the left one is closer than we are to the unknown, so our left and center needs are served. Basically just both of these. That's all it really has to be. Don't even consider the center one. The left is served, and then once the unknown is further away than this one, then I say, all right, the right is served by this tree, so then we can drop that one and save on memory. And the reason I need to do that, I think, is because I could have very large, like I would have, I think this length of the screen is like 45 vertices. That's 45 meters. I would have like hundreds of meters, right? If I just go here and I look at it. In fact, I could even see this marker 3D is already 600 meters to the left. So if I were to have a region like this large, what would it be? This would be 1,000. This would be 500 meters across if I were to do a region like this. So I could be storing 500 keys. Maybe that's actually not so bad to store 500 keys. Maybe it's not so bad. I guess the real issue is that depending on the orientation, my thought was I could have something here, a region that starts way over here near 0, so 24, and would extend. I might even draw, like I could literally have one region that extends this far over. So it would be 1,800 keys. Is that still small enough to track every single one? Maybe I should measure that at some point. I should do a population of a region this large and see if turning on the pruning is still faster. Why do I need to prune? I think it's not even just memory, but it's also computation, right? If I want to find, if I start at any point, I need to find that closest column to myself. I could search all the columns. If I search all the columns, I'll be happy that I kept it as a small list. So I have to check like 100 or less than 1,000 columns to figure out which one was closest to me. But if I could have it be like 2,000 columns, I'd have to check 2,000 columns every time I drop a row. Possibly. On average, I'd probably be checking one, because I think generally when you drop back, you're going to be right beneath a column that's already been set or checked. Maybe not, right? Because if I drop... Let me, I guess, diagram it. It could be the case that... Maybe I do use the square tool to fill it. Okay, it's going to fill like that. I guess it's the possibility that I drop somewhere here. And technically I'd have to, if I were to check every key, I'd only check one key and then this one, and I'd be done. But if I've ever placed any trees up here and I wasn't pruning, like say I had this pattern up here, I would have to check every one of these. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'd have to do 10 calculations before I realized that I found the closest one, which is this tree. Because I would have checked it here, it'd be the best one, and then I check here, and this one's worse, so I know for a fact it's going to be this one. Actually, could it be possible that oh, maybe it's not, actually. Maybe I just realized why it wouldn't be the case. There could be a tree here. So I would actually have to check. How long would I have to check? I guess I would have to check once I start getting worse results. I know that I have to go some distance away from that worst result before I know for a fact there actually can't be anything better than that one. So I guess once the distance here exceeds the distance down, or I guess that'd be like a circular thing. Pruning is probably better for this reason, because now I don't know how I know when I can stop. I guess I just know that I can stop when I reach a point where the result, any tree along here must be worse than this one, right? Hey, Yo-Yo. So how do I know when that point happens? I guess I can probably draw a quick circle around this one to maybe figure that out. Is this even? Nope. Because I have this distance, right? I have this distance. So we'll say this is the circle. I guess when I'm scanning across the rows, this cell would be the last one that could be better. And I would prefer, like I said, I've always said that I would prefer one further to the right at the same distance. No longer a subscriber. Yeah. It's been a month already. So I guess what I would just say is I would say literally the best case scenario would be the road just above me, as far right as I'm checking. And if that distance exceeds the best distance that I currently have, I know for a fact that I'm never going to find one better, because everything that I could test will be worse than that one. I guess that's how I know when I can stop. So it's not necessarily as soon as it starts getting worse, it's once there's no more possibility for a better option. I guess this still leaves the question of whether or not the pruning is going to be better than not. I think for testing it will be, because instead of checking all these trees that probably could exist up here, I would definitely have culled all of these trees previously, because literally this one tree basically would serve everything. I guess maybe it wouldn't. I think the fact that this tree and this tree exist would cull them, but this tree alone can't. It could only cull this one, I think. Or no, it actually can't. Well, this one can be, because this one has two trees on either side of it. So that one could be dropped. But yeah, the tree has to have a left and a right neighbor to be removed. I mean, technically they would be removed because this line exists underneath it, so that one gets dropped. This one gets dropped because it does have a left and right neighbor now, but these would all stay. I guess if I'm also doing this correctly, I also know that I should be dropping this one and this one, because technically they do have a right neighbor. It's on the same row. A right neighbor on the same row can overwrite you. Yeah. So can a left neighbor, actually. A right and a left neighbor on the same row can overwrite you if you reach them before you reach the unknown. So I guess I'm just checking in order. Ordered. Doesn't he be ordered? Who wants muffins? I would. I could drop that one because it would have a left and right neighbor. I get here, I could drop this one because it has a left and right neighbor. I could drop this one. This one actually does have a left and right neighbor. This one can't be dropped yet because it's possible we could end up somewhere way over here in the mesh and be like, okay, well, the closest one is literally this one. And it will always be this one, I think. At least until... Yeah, I think going down... Wait, is there a point where this one... Oh, I guess like I said, if I... Oh, wait a second. This is weird. What are you doing? I'm trying to visually prove some things about tracking instances that I've placed. Just so I don't have to remember them. I feel like there is a point where this tree here is always going to be closer. No. Because like I just said, if I'm reading very, very far away, there is eventually a distance where this tree is closer to a point way out here than this tree. There is a distance at which this point is closer to this tree than this one. So yeah, I can't, there's no way I could ever prove that. If I knew the shape of the entire mesh underneath, I could, I guess, determine for a fact that I will never reach that point. But I can't. I can't calculate that every time. So yeah, it has to have both a left and a right neighbor. I key it by column, so one column is always overwritten by another one. So a tree down here overrides that one. Okay, cool. I think I've proven it enough. There is a distance at which this tree will be closer to this point than this one. Or a point somewhere over here to the left. Thanks for asking about my days, by the way. Unfortunately, I didn't sleep at all day at work. I only binged YouTube until 5 p.m. No early leave. I didn't ask about your days. So don't say thanks. So you've gone to work twice now and there's just been nothing to do? That sucks. I guess you're still getting paid at least. Alright. I think I'm ready to go with it. So when I complete a row, oh, a method that is, I think all it needs is just, yeah, it only needs to know tracking. It also needs to know its current location. Which I guess this actually would happen not here. This happens at the top. Every time we go up, we would put in tracking here. And I guess VX does have to be set here just in case it's been changed. Needs to know the coordinate. And I'll be making that a function so I can potentially drop it later. Or just skip the function call and see if it's faster or slower. I think until I get something very large, it's going to be slower. He's just a bunch of text, Olmec. Man up, you can be rude. What? When I said that, I meant it's like easier for me to be rude and feel less bad about it. So tracking. I guess really I'm actually just looking at my row. Is what it would actually be. So this should be row, which I increment at the bottom. So now I can actually take that off. I'll move that here. I guess I actually only need to do this up here. Or I guess, oh, I do it at the top, so I don't run it a final time. I can run it a first time when it's empty. That's better than running it one extra time when I don't need to. With possibly a lot of data and a lot of stuff that could happen. Red Dead Redemption is free to own on Epic. Oh. When did that game release? Is that too early? Lying. Okay. Stop doing that. Alright, so yeah, put a prune tracking call up here. And I'll go ahead and write this. The prune tracking should be good before I continue. Switch to turn this off for timing tests. Because I definitely need to measure this one. It might be not a big deal to use a lot of memory if it goes a whole lot faster without this. Because it probably will go a whole lot faster. This is a probability, for sure. I can't prove that it would be faster. And I can't prove that it will not be slower. Because it's more things to do, so. Okay. We'll use instances from the tracking dictionary. If later... If later instances are provably always closer to row. An instance must have a left and right neighbor in the same row or below and closer in the X dimension than row. Okay. So I go through each one. They should always have a left and a right. And tracking, I think, is keyed by... Tracking should be keyed by instance type. Vertex to instance ID. Okay. So it would actually be instance ID, then keyed by vertex. Instance ID, key, vertex key. I guess it would actually be column key, and used flag. Because if I have any distance density checks that depend on the closest instance of a certain type, then yeah. And then this would also have a left and a right. And a smaller set. Okay. I'm just going to write out exactly the layout of this thing. ID, int, to then column, int, and then to used bool, and then left column and right column. So whenever I place one, I'm always going to put in the tracking list at this column, and then I just mark it used it when I place it because I know I probably shouldn't be trying to prune it yet. And then from the closest instance I found, I set this one's left, and then I would go to that column and set its right to myself. If I'm closer than its current right. Or, I guess it also needs to have a row. Because if I'm further down, I'm always overriding it. Yeah, no matter what. If I'm lower, then I'm always writing it. So I guess I also would have to track this at this point. It's probably definitely a pruning thing. Well, here's the thing. I'm adding this data. A left is a column, a right is a column, and a row is just an int. So this is what tracking looks like. But if I was just tracking it by key, I would just have int and then column keys to null. So this is what with pruning and I'll say what it will look like without pruning. Because this has a very different memory size. Absolutely. Because the dictionary is not very free. Which just... yeah, it is null. So without pruning, this is all I need. With pruning, I have to keep track of all of these items. Red Dead 2 free on New Year's. Almost Diamond 2 tank. Wow, nice. Okay, so... this is a big memory footprint. It's probably going to be way better to just keep track of the columns. It's probably way better to just keep track of columns. Seeing the difference in, like, memory here. Because I have a few keys here. These are going to be the large dictionaries. So they should kind of make up for that, because I just have column ints as keys, so it treats it like a set. Confirmed. Oh, Mike, order me a pizza? Why would I do that? What is this? Oh my god, that is so loud.
Make me a pizza.
That was so loud. I have it too. I played the whole game. I still remember this. I was so into that. I literally woke up one morning, got breakfast, started playing it while I was eating, and I pretty much played it literally the whole day until I went to bed. I only got up for the bathroom and food. And then I went to bed. That was one day though. Binged it as well. Yeah, I really liked it. So maybe I don't even attempt pruning because of the huge difference here, where this is going to be stored for literally every column. And I could just have the keys. An integer key. That just maps to a null value. Rather than doing this, 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 and this. Honestly, this extra bit kind of really threw it over for me. Having to store an individual dictionary that looks like this for every single column, I think it's too much. 3 stream streak. Nice. Only The Last of Us 1 hooked me this bad. No other game reached these two except Firewatch. Maybe a controversial one. Well, Firewatch is a really short game too, right? Firewatch is a weird game. It's got a weird story. Yeah, Yulia has apparently not missed a stream in 30 days. It's crazy. I mean, I've never missed a stream. Because I have to be here to stream. But, alright. I'm going to say for now, this actually will do nothing. Due to memory use, I'm gonna leave this unimplemented until I do timing tests with large regions. And if locating the closest neighbor is the biggest time usage, you will win. Yeah. I mean, technically I've already won because you weren't here my very first stream, so you can be... You could have the record for sure. You could probably already have a record that will never be beaten. Twitch won. Needed for pruning. This unimplemented until I do timing large regions. And if locating the closest neighbor is the biggest time usage. So for now it's just gonna be doing nothing. And I guess I can comment it out as well, since I know I won't be doing it ever. Okay, so tracking. I will do a const. I actually won't write it until I get there. I think I need to... Do I need to move the window? Maybe I just increase the brightness. Oh, man. I did figure out that using full... Apparently this thing has a limited and a full color range. You can see as I flip back and forth, it kind of drops the contrast a bit. I did find that out. Uphill battle. Yeah. Overwatch has got to figure it out. I feel like you should see an uphill battle on a game like that, like 1 in 100 games. I feel like it's 1 in 10. 1 in 10 games are an uphill battle and they weren't even close for the winner. I think they said something about their like accuracy rate or something, which has got to be wrong. I think they must have lied about it. Where they say like 90+% of games are within like a 5% margin of fairness, their computed fairness value. They're within 5% and they're accurate. Most of the time, they're not. I think maybe what they meant was their system puts the majority of game, like 90+%, within a 5% margin, but then their accuracy in that area is probably like below 60%. So they probably have like really, they estimate really close games, but their accuracy is definitely not better than like 90%. It's probably like in the 70s, 60s or 70s. Gotta be. Maybe in 50s. Because I have to include games that I've lost badly that say reversal. Or games that are just close and they say reversal. Which in that case, I think you only get reversal and uphill battle if it's like 10% or greater. If the deviation is like 10%. Like it estimated a 60-40% chance. They hit you with uphill and reversal. Which, I mean, they must be lying, because if they say the majority of games are in this like 5% range, and it's rarely ever uphill battle, and I feel like at least half the games are uphill or reversal, they're definitely lying. Or they're just like using, or their stats are like inflated from like bronze and silver games. Okay, populate instance. So I have an instance settings that I want to set. I have the data, which is, data is, oh, this is, okay, so this is also for pruning. But this goes away, I think, because now I'm just using tracking. Yeah, I'm just using tracking. I'm not actually using this anymore. So oh no, this is per instance setting that I have. So I would be updating this per each instance. Do I need to store a vector too, or do I just need to store a distance? Maybe I only need to store a distance. Because I'm checking myself, and I'm also considering the fact that the one behind me, I don't need it. I can exclude that one. But I don't know which one's behind me. And you know what, maybe I think remembering the last one that was closest to me is better, because then I only have to scan forward and up. I don't need to scan backwards and up. And then I can exclude a huge region of that, because the one previous to me, I can exclude that. So I don't even need to really know. I think I just need to know like this front thing I can't use. I think just closest needs to be a point, so I can like properly compute the distance to this point. And then I just know my coordinate and the coordinate behind me are excludable. But I guess I also actually do need to track a last. because if I start on a new row, this is going to be like the column. So I'll also just make it vector. An integer. Okay. Can I make a constant value up here? Okay, cool. It's fine without being a constant. Nice. So I can write int max. Okay. I was just checking to see if there's anything there that I can read, but there's not. Let's write int max. Now it's clear. So this is the last column that I was testing for this instance. If my column is ever below this one, then I know I need to update and like determine a new one, or if it's the first one. If I have nothing in tracking, then I just assume that I'm a max distance away. Which now that I think about it, maybe this is not the right thing to do. You know what? I've got to wonder here. Is it still here? Okay. There is a get closest instance thing. I want to see how that works. I'm sure it must be slow. Mesh asset ID closest to... so that's weird. Why can't I specify which ID it should be? Odd. Okay. So I start in my region in my cell, and I get the instances. Oh. So it's only by region, which is also really annoying. Okay, so yeah, this is a really bad. I would even say this is a useless function. What, like what? What are you doing? What use would this have? Seriously. You don't even scan other regions. You literally don't scan other regions. In fact, you only scan in the cell that you're given, which is crazy. This function is useless. This is literally a ridiculously bad function. like every edge case that you would want. Like, okay, what about the next region? All right, well, if I say get closest mesh ID to this point, which is on the very edge of a cell of a region that is full of mesh IDs, it will say there's nothing because we're only checking the cell that you requested. That's really bad. And weirdly, there's just no... You can't specify which mesh ID either. I would almost say like get closest instance and provide a position and an ID to say, oh, okay, well, I want to search for these IDs. I want to search this and these IDs, this position, and maybe even an area too. Maybe even say, all right, but I want the closest one, but also no further than like 10 meters away from it. This literally doesn't do anything. I would say this is almost even... I would say this is so bad that it's like... bad. I would say it's so bad that it's bad to have the method at all. Someone would definitely use this thinking it's just going to work across cells or across regions, and it's not. It would not. You would start using it and be like, oh, why is it like telling me no? And you find out, maybe you do testing and you realize, okay, well, if it's here, it can't find it, but if it was an inch closer and my position was an inch further away, so the distance has changed, now it can find it. And you realize, oh, because I just moved it into the cell. Yeah, this is like, I would say this is like dangerously bad. That's crazy. So here's the reason why I thought of that. Region edges, where I have one region and a different region. I guess in that case, what I would do is I would just have one region for like the whole forest. And I would only use a different region when I can like cleanly separate them. Like there's a small river, I guess. A river could cleanly separate it. Because then on the edges, if I were to take two different regions and snap their edges together, I'd have to go through there and make sure they're not stacking instances, essentially. I'd have to always make sure they're at least one. I can't have two regions touching with the same instance settings, because they could place instances on top of each other. There's no check for that. When I just realized something. With this, there's a problem here. This can actually move it outside of the region. So in each dimension, if I'm outside, I snap it back. Or I guess I just don't allow myself to move it if I go outside the region. Yeah, I get adjust the window now. actually make it... It looks a bit blurry. Bring this up. And then drop this. Okay. Yeah, so I'll just do another test. Well, actually, I know that this won't be true, because I'm staying on the same vertex. Actually, I guess it can. How do the holes work? The holes should go by vertex. So if my vertex is not a hole... Let me go look at how holes work. I'm just going to zoom in somewhere in wireframe and then draw a hole. Just this. So wiggling it could actually move me out. That is possible. Because deleting one vertex deletes... essentially prevents me from moving this direction here, this direction here. Yeah, so it affects too much. Okay. If we were to just make like a diamond shape, I think I could probably work with that, or like a half diamond shape or something. I could work with that, but because it actually totally... it removes too many vertices, I guess. It also has this like unfortunately weird shape. I wish it wouldn't have this like that. Let me go look at the whole logic, because awesome. For some reason it is defined in the header. For some reason. But where? What? Am I missing something? This function just doesn't exist. Is this a define? What is this? "3D util"? I'm so confused. Crazy. You know what? Actually, forget it. I actually don't care. If I notice that, I can delete it. Note. Don't care about moving outside the mesh / holes. These should be these should be so rare that it isn't worth the time to test. Mistakes will be manually fixed as needed. Yeah. So basically, if I know that I'm putting a region over top of a hole or next to a hole, I can just go to that hole and just check if it's in a bad spot, if there's anything that was put in a bad place. If it goes outside the mesh, and I know very much that I had this mesh like placed right next to something that I should not be intersecting, like it's near a wall, I just go to the wall and I check if there's anything intersecting it and I delete it. Right. Okay. I think at this point I might just drop the custom transform thing entirely. And just have like prompts. Like, hey, you're about to delete a bunch of instances, or you're going to add instances to this region and there's already instances there, that kind of thing. And then I should definitely make it like an undo redo thing. Or just be careful. Just be very careful. Okay. So this data is so I can minimize what I'm checking. The last is just the column. I'll even write it all out. Last column. And this is the closest instance that I care about for this instance setting. I think I may I'm wondering if I want density based on two functions or two possible instances. Like, a tree can't be this close to this other tree, and it also can't be this close to another tree. But I guess for density is specifically closest to itself. Okay, I got it. Okay. There's a lot to write, so I guess I'll just do the first part. I'll just compute probability in place. Nearest afloat. I'll just put in 10 for now. I need to compute this value. And output. Output, I need to remind myself what that looks like. Output is an instance ID map to a packed 32 array. Okay. Okay. So now I think I just want to test this. This is treating it basically as if everything is always 10 units away or something. All right. Let me do this. Do I have any painted triangles? I should not. Okay. So here's what I'm gonna do. I'm just gonna draw kind of a very large area here. Now I get to see how annoying it kind of is to use this. Yeah, so I guess I just joined back to this one. And then I'll just stick with this for now. Okay. There's island 1. And then I want to test having a second island. Ooh, I missed. Okay. So I'll join this one, and then I'm going to delete this vertex. And then drag this over here, and then replace it. Okay. So if I miss, not a big deal. It's pretty easy to fix. Okay, island 2. And then I'm going to draw just a big square in the water here. A very large square in the water. Yeah, I should probably figure out some way to make these points grow. Or maybe do something where, like, if I'm near the point, it will snap it to an existing vertex. I'm not sure how I would do that, but... Okay, there's my big square. I'm going to make it a little bit larger. I'm going to make it up here, actually. Okay, so now I'm going to hit save. Set this up. Density 1. Density is going to be kind of ignored. I'll actually set this to 0.1 so it's kind of low. And then I think I'm going to go ahead and add this. Add that. So that I can I'll just add everything. Just so that I can kind of restore from this point. So I could write, if this stuff gets lost or something, I can just say git restore these two files and I'll bring it back to how it was when I staged it. That should be how it works. Okay. Populate. Very, 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 very slow. Very slow. Okay, so it's taking too long. I'm going to assume this is a crash. I'm just going to stop it. I'm going to assume that I missed something. It should not have taken that long. I'm going to assume I made a mistake somewhere. I could have it... Where would I have made the mistake? That while loop is correct. I think what I will do is after I complete a row, I think I can do like an await signal thing. Await. Get tree. Process frame. And I'll do a print row completed. Instances added. And I can just get the size of I think this should work. Okay. Okay. Invalid function, invalid call to append array. Expected 1 argument. Line 670. It crashed, by the way. It printed all that and then it crashed. So I was unable to scroll up to see the other logs. But I guess line 670 I have a problem. Oh, I do have a problem. Whoops. Invalid access to property key X forms on a base object of type dictionary. So it should be reading X form and color, I think, not X form. So I guess I'll just assume that this is a mistake that I've made here. When I'm building it. So it actually finished, which was interesting. Which is odd that I got a crash before then. It's kind of odd. Trees are here. This is way more dense than I thought it would be. So clearly I didn't have a very low I did not have a low enough density. Alright, that's a good test. That didn't take very long. So why was it so bad when I wasn't stalling on a frame? I guess this just means it's probably a good idea that I stall whenever I do this. I could say that after I add... Well, no, it's probably better to do it by row. And maybe I should do a timer where I track a delta. And once I take longer than some amount of time, then I stall. Check Discord right now. It might even be a good idea to after I finish a row, just go ahead and send it off as well. That could be too much, I don't know. I don't even have Discord open. Cool. What is all that stuff? I don't know what that is. Neat. Good normals now. Probably turn off the camera. I guess I can do that. Normals. Yep. Looks good now. It's pretty cool. I guess that hole went away. That hole was never meant to be there. Yeah, I think I'll just stall at every row because it could be pretty slow. And then I can do some process or some percentage checks. Like every 10 rows I output a percent progress. So y2 should be a larger value. So this is how many I've completed. So it should be a positive number, right? Oh, I guess this is actually how many I have left to go, which is honestly the same thing. And I guess I just count them up. And then percent completed. Y2 minus VY is what I meant to type there. I would need some holes? Okay. So how many have I completed? Oh, I guess it would be something like... Oh, I would do this number should be greater. And I'll do it at this point instead. So to my add, I await a frame. But I guess I actually should probably wait here instead. And then the total, this is weird. What is this number? this would be... I guess the span. So... So this number is always smaller. And this should give me a positive value as well. So as this number approaches this one becomes closer and closer to 0, which is wrong. What would it be? Is it the same thing, yv minus y1? Yeah, this is it. Or vy. As this gets closer to y2, this value gets closer to this value. Okay, that's the math. Okay, cool. So if I were to clear region, oh, okay, so it actually failed. Oh, and I know why it failed, because it moves them outside of the range. Damn. Okay, I'm gonna add that test back, I guess. It's probably not super expensive to add that test, so I'm gonna add it back. Yeah, I've actually just realized what's going on, so I do have to do stuff like this. I have to reset these. How hard are you hitting her ribs if she comes up with my past doesn't matter, what matters is that I'm yours now? Interesting. Interesting question. It does matter to me that they are serious about the relationship. I will not be punching anybody. And I will know the answer to that question before I get into a relationship, so... I guess I leave K where it's at, and I... Okay. And then I say, check that we're still in the mesh. Do the same thing again. Reset. Okay. So if we end up on the edge of the mesh and we go out of it, then do that. Okay. So now I have to go and paint these away. And this menu is still like weird and broken. I love my 100% strength still randomly choosing to not delete things. Awesome. And I should have 1 because there's a mystery tree somewhere that I can't find. I really wonder where that tree could be. Okay. Back to this. So I'm gonna do a test. I'm gonna do a test again with a new percentage. Okay, so I messed up my percentage. I guess I'm doing integer division. Is that what's wrong? Yeah, it was integer division. That's the mistake. Alright, but then I should be able to click clear and they all go away. Awesome. I'm going to turn the density down even further, because it's still apparently way too high. Actually, I think this was meant to be sparsity, so I think making it low was the mistake. This value gets lower the higher it is, right? Yeah, that's way lower, I think. Maybe not way lower, but at least the percentage output works now. Okay. Clear. Let's go to 5. It's like really slightly less. Yeah. And it's still super dense. It is still technically random. It's not actually checking distances yet. So I should be able to still have some that are right next to each other. Yeah, I do. In fact, those intersect. Cool. That's way too sparse, I guess. It is really slow, though. This is kind of a small region, and it still takes, like, I mean, I guess I should count it. Let me count how many seconds this takes. Clears really fast. Let me turn up the density. Or down, which actually increases it. I'll go and put a timer on it. You see, Kojima had a heart attack when the waitress told him his food was going to take 33 minutes to be ready. I feel like that's not too uncommon. He didn't get the joke. Okay. I get the joke now. That's not an easy joke to notice. That's pretty cryptic. Okay. And I won't time this one. And this is microseconds. So I think that's 10,000. Okay. All right, populate. Four and a half seconds to do that. So that is pretty dang slow. Just at a base case of like kind of doing nothing. It's like really simple right now. I'd definitely like to make it faster, for sure. Maybe I should go and look at how to make this faster. So, what could be slow? Perhaps I exclude this part. Maybe I should go ahead and exclude all of this, actually. So I'll exclude that, and I'll exclude that. I'll just get rid of that. I'll even exclude these two calls. So I can just time stuff that I can like actually kind of control. So 4.5 seconds. Whoa, what? Wow, alright. So the await adds a lot of time. So never mind, this is pretty fast. Though it's definitely not 0.3 seconds. I don't know where it gets that idea from. perhaps this time is also slow. So I guess I will time this part as well. Get... I guess I'll time that as well. So there's something going wrong here. It's definitely not... I might be calculating this wrong. Is that really 0.3 seconds? It's like a second. I feel like this is about a second after I click it. But it is still pretty fast. Okay, so what was the bug earlier where it like totally froze? I don't know. This is so fast actually that I am gonna drop. I'm gonna drop this call completely. I will bring this call back to see what effect it has on timing. Almost nothing. Actually, almost nothing. So maybe I can bring this back for this test, and every 100 rows I will stall. That's still really fast. Okay. Okay. So 100 is pretty good. I only got 3 stalls there. Dang. And I guess I will also do this here at the very end. I'll keep track of the total as I go, I think. Or I guess I can actually track a total out here. So every time I do this, probably 10,000 instances in 0.3 seconds. Alright, awesome. This is so fast. That's way faster than I expected it to be. Alright, now it's only downhill from here. So I'm going to run this test. I'm going to do this 10 times with the current options. And okay, I'm not going to do a proper timing test yet because I still have this density factor isn't actually properly used yet. So populate probability, I'm going to go ahead and make this be 10 over the density. So I'll see what a small value does. So it was 10,000. And then, in theory, a lower number. I don't think it's going to have an effect because, like, I'm not doing the density stuff correctly yet. I'm not computing it right. I guess that actually did have a pretty big effect immediately. Okay. Alright. I'm going to add the tracking. So I can just remember that it takes about 0.4 seconds. Sometimes in the 0.3s. Alright, so now I'm going to go ahead and get this closest thing working. So what I need to do for that is my tracking is keyed by instance ID. I only need to check my current ID. So I will do get or add my own instance ID. So I guess actually what I will do is I'll say nearest is clamped by density, so this will take an infinity and fix it, so it won't be insane. So that's good. So we start that with infinity, and then if tracking has instance ID, then I need to do something, and if I don't, I will say if not tracking has instance ID, we'll do tracking set instance ID to a dictionary, which will contain that. So tracking is just int columns. Okay. Well, I guess actually this should be a height too, shouldn't it? It's a column row. I'll go and lay this out. Okay, to column row. So I need that for distance checks, okay? So run that. If we have this instance ID, then I do inst map. Instance ID. And then I say essentially I have to find the closest thing to me. Data should remember where that is. And I guess to do this check, right? So if my data, where is it? I probably need to like copy this down here so I can see what it looks like. And then data, I need to copy it so I can see what it looks like. Last column. Int. Closest. Vector 2i. And this is what data looks like. Okay, so if vertex x is less than data last column, yeah, so this just means we've gone back. You're gonna see dogs in a second. I gotta mute. He was not happy. Good boy, it's okay. Gone back, must get new closest. So, essentially my plan is going to be that I run through. Yeah, I'm just going to say I have to fully recompute it. So I have to run through all the columns and find the closest one to me. And then that's my new one, right? And then I say, if my closest is currently empty, then I know that I don't have anything. Unless you're Kojimbo. Okay. Just said it in French. And then data, closest will be equal to vertex, which vertex should be vector 2i, yep. Or last column. I guess this is always going to be the case, right? So I don't even need to worry about that. So we skip this check if we have never placed something before. If we haven't checked yet. So we literally could not have done anything yet because last column is nothing. Okay. The video on honey dropped. You didn't know. You didn't know what? You didn't know that honey was, like, shady? Guys, free money, please. Free money. Have some free money. A second one existed? Maybe you mean to say like that they did two different things, or I don't know. I don't know what you mean a second one exists. As if only one person ever made a video about it. So when I get a new one, I'm just going to go through the instance map. Yeah, so this is where the sorted keys would be good. Perhaps tracking, whenever I add something, needs to sort. There is a sort thing. Source addiction in ascending order by key. Ascending order. So maybe the fact that I have to keep this sorted. Um, this dog is like waiting to see these dogs walk by again. Okay, he gave up. Oh, set. Does this return a... It returns a boolean. Does it return a boolean if it's... I love undocumented stuff. It's my favorite thing. It just always returns true. Okay, that's cool. Love that. I'm assuming that since it stays sorted, it should be easier to keep it sorted. I wonder if I could even tell the dictionary to stay sorted. Because I feel like if it knows that it should stay sorted, then it might have an easier time sorting. Dang. This could be a huge slowdown. This sort could be a huge slowdown. Which is why perhaps pruning might be better. It will save time, so we don't have to keep sorting it. If I ever add a new vertex I haven't seen before, I have to sort it. So that's what this is. Oh, I was gonna say, what is a sign? I remember. Okay, so we went back. So for column in instance map, I guess I keep track of points. Whoop. Okay, then I can compute a best value. So best will be distance squared to points. And I guess I can actually do this right away. Stop early if it is impossible to be closer than best. So essentially this would just be we'll say point y. I don't know. Oh, I guess what would this be? What would this be? I guess I can just say if column. This is probably the best it can be. And best needs to be infinity. This should not be best. Or distance squared is, and this actually would be, it's actually always going to be an integer, isn't it? Yeah, it's always going to be an integer. I thought so. I already passed it as a square root, so I actually just keep it non-squared. I actually say nearest squared be an integer. Into max. Best squared. Or they're the same, and the actually I guess if they're the same, then I am using it because column is going to be higher. So it's going to be equal to, and I'm going to do a note equal distance favor further right point when equal distance. Stop if it is possible to be closer than best. So this would be the case where the difference between me and column squared is higher than best squared. Max square will be equal to column minus vertex x. I want the distance between these two. So I want to do the larger number minus the smaller number. But is there a way to get this value as a positive value? Because if column is -2 and vertex is... Well, actually, I guess I know. when the column is greater than or equal to... Yeah, just when the column is greater than the vertex x, then and then if max square is greater than best square at this point, then I can break. Stop relative to possibly closer than best. So we started getting worse, or we have a possibility of getting worse because we have passed our point. We've passed ourselves. And if that column is so far away that even if it was on the same row as us, it would still be, that distance would still be worse than best, then I stop. Okay? Best square is this, and closest equals closest equals point, actually. Okay. Otherwise what I can do is an optimized test, only scan forward, discount excluding columns, which would have been tested by the prior, which would have been tested on the prior column. Okay, so then we're going to do the same thing. We're going to do column in instance map. Skip columns the last would have tested. So I can do the distance squared. This will check up to the distance squared to its point. So I'm going to do var last squared will be data looks like this. Just reminding myself. So last square would be the data closest distance. Now let me do this. Vector 2i. Last column actually would just be yeah, I can only exclude the last column that was tested. Because I could do this and then skip a huge gap and then go forward. So this one I have to exclude a smaller area in case I do a large skip like that. Last column and my current row, distance squared to data closest. So that's the last squared. So I know that if I can probably go auto mode now. Nice. You know, the world needs me having a Gundam. Like the toy ones? Or a real one? So I skip columns. The last column would have tested. So this would be I guess what this means is if I feel like the shape kind of goes up and above me though. So there is a set of columns that I can definitely exclude. I think I can definitely exclude columns prior to the last column I tested, right? I can absolutely exclude those. I can definitely exclude those. What do you think, Genius? Skin will never come out. Dude, what? So you're saying you need a toy Gundam is what you're telling me. You can get one for... You can just go get one. Just go get one. Sure, why not? Yeah, this one can definitely exclude that. So then what I can do is I can definitely exclude those ones. I thought I needed this last squared though. I guess I can kind of do this. The column that I'm checking has to be at least last squared distance away from that. I think I can probably just test it, honestly. I guess because of how I'm storing the data, the column just points to a row. And I can just do the same thing again. Stop early. if the best option is too far. So if the column is greater than, which is actually going to be true. So I guess in this case, no, I do have to check this. So if I pass myself, because this handles as well if there's a large gap between the current vertex and the last time we checked. So we could be checking backwards a lot. So stop early if the best option is too far. So it'll be very similar to this. Not sure what's going on there. Okay. So I guess I'll just be doing something very similar to this. But perhaps, yeah, I don't need last square, do I? I guess I don't. Best square will now be equal to my current distance to closest. So best square will be distance squared to that. I guess I don't need that anymore because I just write directly to it. And then point. So I say if max squared is greater than best squared, I stop. I definitely can't find anything better. And then and now I'd use point. Which maybe this is... No, because I would be writing it back to closest, so... It's probably fine. I guess there should be vertex distance squared to point. This might even be bad, actually, too. So maybe I should avoid writing to this until I'm done. So I just write closest. And then if new closest is not equal to max, then that. And also nearest square root equal to best at that point. Murder those strangers. He will not be doing that. Is this all correct? Last column. Then closest. So we went back. Must get new closest. Stop early. Visit and possibly be closer than best. Favor further right point when equal distance. I must write this as well. You're a beast who unfortunately can't read. That's funny that you say that. He can't read, so he doesn't even know what's been asked of him. So if anything, he understood what I said, but he does not know what you said. That weirdly rhymes. I don't know what I said. Forgot. You think he will be sad when die in Minecraft? I don't die in Minecraft. So, that just doesn't happen. Skip columns, the last column would have tested. Skip columns. They would have been tested already. And I guess we have kind of this extra thing at the front. All right, so here's kind of an issue. This is really hard to test. This is a lot of code, so it's really hard to test. And now it includes a sort. So I guess I just run it. Maybe I'll run it for a small thing and see that it works. I'll do a new region. And just do... I guess I'll do like 1, 2, 3. And have it print everything it does. Or I don't know. I literally don't know. If I get a new closest point, print closest to was that. Let's do this print here. Do the same print here. Closest to blank was blank. New closest. And then I'll do every time I add one, I'll print the instance map again so I can see it. Okay. Settings 1, 10, go. It's a lot of printing. I printed way more than I expected. All right. 0.002 seconds. Nice. So we started by placing -1, -2, -1, -2, -3. So we placed here. I'm actually going to turn off the variation so I can see this clearly. I'll turn this off. And run it again with a clear thing. Okay. So -3, -3, 1, 3. Which is just the closest point, I guess. Then we got here. We started here, and I said new closest to 2, 2. I guess it would start at closest to 3, 2 was 3, 3. Which is wrong, because literally one right here that it should have... What? Closest to 3, 2. So 1, 2, 3, 1, 2. Oh, I guess this one. Closest to 3, 2 was 3, 3. Alright, yeah, so that's correct. Then I got here, and it should have picked a new closest one. New closest to 2, 2 was 1, 3. That's correct. New closest to 1, 2 was 1, 3. New closest? Not really. If it's the same, it just shouldn't check it. But I guess it's possible that there could be one here, so we'll check here and like scan for that one. Okay. And every time I add one, I print it, so I put it one at 3 and -3. That's weird. Oh, no, I did that one. Wait, why is it printing then? Why did it print this when it didn't do anything? Oh, it did update. It says it's now -1 and 2. Right, okay. That's why. Okay. Went through here. We didn't find a closer one. It still would be this one, or actually would be this one. And then I get here and it says new closest to 3 and 2. Nah, I should have got here. 0, 1, 2, 3, 1, 2. Yeah, it should have got here and updated the new closest. So it should have said 1, 2, new closest to 1, 2, 1, -2 would be that. So how did that happen? How did that happen? So if we fail, I'll just do this. I'll say else print found nothing closer to do that as well. Found nothing closer to this. And then up here, else. Nothing found. Okay, so now I should get a printout every time. Except for the first run. So I guess I'll say do an else here. First run, no instances. All right. Now let me look at this. Okay. First run, no instances. Found nothing closer to 2, 3, 1, 3. Nothing closer to 0, 3. And then it should have said immediately, found nothing closer to 1, 3 than 0, 3. Okay, so that's correct. Yep. Good. We drop down here. Closest to 3, 2 was 3, 3. Should still be this one. Nothing closer. New closer to 1 was... new closest right here was 0, 3. That's good. And then I placed one, so I got a printout. And then I say... I should also get a new closest right away. So new closest to 0, 2 was 0, 3 because it is that one. Nothing closer than 0, 3. I placed. Nothing closer than 1, 2. And then I placed. Nothing closer to 3, 2 than 2. We got here. Let me print out the rows and columns because this is actually kind of getting difficult to follow. Put it at the top, actually. Okay. All right. Cool. Row 3. First run, nothing closer than 3. And I placed nothing closer than 2, 3, 2, 3, 2, 3. And then I placed, and then it would be 1, 3. Still 1, 3. I guess that's 2, 3. Then new row. Row 2. Closest was 3, 3. New closest is 2, 2, 3. And it should be nothing. And then here, after closest to 0, 2 was 1, 3. Good, that's right. And then I get here. Place. 1 and 2 is 1, 3. Or I guess it's actually this one. Or no, yeah, it's just this one. Say new closest. Oh, weird. Okay. So every one of these is a placement. So after I place this one, I'll leave it highlighted so I can track it. I go forward. New closest to 1, -2 is 1, -3. I'm gonna guess that's right. I guess that's fine. But then it should become the closest one. And then we would place. So then on this node, new closest to 2, -2 is 2 and 3, which is right. Found nothing closer to that. Okay. It did break at one point, which is weird. I'm just going to highlight the second one just so I can spot it. 3 and -2. And then found nothing closer than -2 and 1. Wait, -2 and 1? Oh, no, I'm reading too far down. Then 3 and 2, which is right. Then we place, and then this is now the new closest one. Then 2, 1. Then we place. And then we should pick the one above us. So new closest to 0, 1 was 0, -2, which is correct. And we placed. New closest to 1, -1 is 1, -2, which is correct. And then we would actually put nothing closer. I do need a distance for the probability, at least. So I was thinking maybe I could cut that out of the probability check. But I think not. Row 0. Closest to this one is 2, -1, which is right. Then we placed. And it should say, should say this one's the new one. New closest to -2, 0 was -2, 1, which is right. And then we actually end up placing. So this is the third placement. New closest to 0, 0 is 0, -1, which is right. Found nothing closer than 0, -1, and then we placed. Nothing closer than this one, nothing closer than this one. Good, and then we placed. Alright, so now the real thing is to make sure that the positive numbers also work. Closest to -3 and 1 is -3 and 0, which is right. New closest is that one, which is right. We placed. -1, 1 is -1, 0, which is right. Then we placed. Nothing closer than this one, the one right behind it. It's good. And this one would say 1, 1 is 1, 0, which is correct. And then new closest to 2, 1 is 3, 0, which is correct. That's what it should have done. And then we placed. And then it says new closest is that one again, which is fine. I'll just keep walking through it. Because I feel like I saw a mistake, but maybe I was just reading the output wrong. Closest to 3, 2 is 2, 1. That's right. Nothing closer than 2, 1. Then we placed. New closest should be the one above it. Is -1, 1. That looks right. Then we placed. Nothing closer than this one. And the new closest to 1 and 2 is 2 and 1. Oh, I'm here. Right, this row. 2 and 1 is... Oh, sorry, 1... New closest to 1, 2 was 2, 1, which is right. Because it was checking this one, so this one's now closer. And then it would place there, and it will also say newest again is 2 and 1, and it placed, nothing closer, and then final row. Closest to here was -2, 2, nothing closer, and then we placed, And then here, new closest to 1, 3 is 1, 2. That's right. Nothing closer. All right, because this one or this one, so nothing closer. And then I hit this one, and it says new closest to 1 and 3 is 1 and 2, which is right. New closest to 2 and 3 was 2 and 2, which is right. Found nothing closer, and then we placed. Okay. All right, so I feel like this is working. I'm going to delete the 2 triangles here and I'm going to do something like this. And see what it gives me. Okay, so let's see if it was correct. First runner, no instances. It should have started here, I think, right? The first one didn't print for some reason. Is that possible? It placed one and didn't print. I guess that's right. That's what I've been seeing. It places and doesn't. Yeah, because it just does this, so it doesn't print it. I should probably bring it out here. What's wrong with this? Oh. Yeah, fine. Just do that. Found nothing closer to 1, 3 than 0, 3. That's right. Then we placed. Nothing closer, nothing closer. Then we would have been here. Row 2. Closest to 1, 2 was 1, 3, which is right. We did nothing. Nothing closer. Which is correct. And we placed. Nothing closer. Cool. Row 1. Would be closest to 2, 1 was 2, 1 was 2, 2. That's right. Nothing closer than 2, 2. And row 0, closest to -3, 0 was 0, -3. Yep, I mean, that would seem right. That would seem correct. And then I jump over here. New closest to 3, 0 was 2, -2. That's correct. And then closest to 3, 1 was 3, 0. Nothing closer than 3, 0. Then we placed. Row 2, closest to 3, 2 was 2, 1. -2, 1. That's correct. Nothing closer, and then we placed. Row 3, closest to here is probably this one, I think. -1 and 2. That's what it says. Nothing closer than -1 and 2. Then we placed. It should say it again. New closest is -1 and 2. And then it should say found nothing closer than -1 and 3. Okay. Seems good. Seems good. Kind of the unfortunate thing is that if there's a bug here, it's kind of really hard to locate it. So I'm gonna go test the big region now. I'll leave the small region here for fun. And I need to go get rid of all those printing because that is gonna be so much printing. That alone could probably lag it out. Okay, I'm gonna double check that my prints are minimized. Minimal. Okay. Now let's see the speed of this. Go ahead, save before I run it. And I'll leave that at 1. Populate. Alright, so that was pretty quick. I don't yet have a minimum distance in there. So I guess I should go in and add the minimum distance and make sure that the minimum distance is working. Because this is kind of the test that it'll do it on. So for now, I'll just leave it a minimum between. And everything has to be at least 1 meter away. So I think what I'll actually say is like enable self-distancing. As like a Boolean check, so I can like skip a lot of things. And then I have this. I don't think it needs to be any more precise than 1 meter increments, or 0.1 increments. But it can be greater. I'll start this at like 3. If there should be minimum distance between this instance disabling this should improve population speed. And I'll say self-min distance again is like at least 1 meter away. Because if you turn it on, you want to be at least 1 unit away. Okay. Now I go here, and I can check the self minimum distance. So essentially, yeah, I think I'll do kind of this same thing up top. So I'll just copy this because there's a lot of stuff you can cut out. If it can be near itself, you know what? I'll say this actually. Enable min distance. Actually, I just won't even have it. I'll do this. So export. Minimum distances. Be an array of int to float. And I'm going to do a custom thing here. Array type and the hint string. I have some special things for this. Where this range needs to be a certain thing. Where is it? Am I missing something? Oh. Hint array. Hint string it. Here's the type of the array. Use hint string format from string to have more control. Okay. So it'll be, sorry, a dictionary actually. Didn't I do this somewhere? This guy. Integer, so I think this is actually supposed to be, that's the type, right? You have the type and then you have the property hint range. So it'd be 1, or I think it's like 2 bar. So 2 is integer. Sorry, jeez. Type float. Okay, so I can't find that one. Type float is 3. Say 3 there. Range. The range is 1.0. 10. This gap or greater. This is 2. Range. -1. 10. 1 or greater. Dictionary. And that updated instantly. Does that work? Awesome. Okay. Cool. And then region will have an optimization at the top. So this will essentially say if instance minimum distances size is equal to 0, minus skip distance test. And I think this bit here, I think I probably want to put this in, or maybe this in a function of its on its own. What can I take out of this? It looks like I can take all of this out of it. I would only need the instance, the data, the vertex, tracking, and output, which I think is all just the exact same inputs. Did I say data? Apparently I can't count. Instance, data, vertex, output, tracking. Yeah, 5. Okay. The signature is identical. And it's just all of this. Optimize skip distance tests. We just put the instance. I guess I just say if populate probability density, and then just you can just pass infinity. For instance. Okay, so these are still getting tracked for like other instances that may be reading them, but this one just can skip all of these checks right here. I mean, I guess I could just say, yeah, because it doesn't even need to track last column. It doesn't need to track any of that information. It can literally just skip all these tests by doing this check instead. Okay. And then now that I have it, I do care about, I need to be at least this distance away from everything that I track. So now this has to be so last column, let me see what data is storing. So this actually needs to store not even a closest thing, but also a closest type. Okay. So I can go through and I can check all of these. And then for column in instance map, I also have a ID is -1. And I guess I can just check ID does not equal -1 instead now. Uh, I guess essentially what I have to do is I have to say, how do I do this? I guess it's actually pretty simple. As soon as I read a type that is too close, I skip. Right. So what I can do is from right here, I can say check that we are least far enough from closest type before I do anything else. Yeah, okay. So if, and this will actually help sometimes when I place, or when I go forward one and I'm too close to that one, so I skip the whole check to like move it up, because I can skip that check right there. That's fine to skip early. Check that we are at least far enough from our closest type. So I want to get so if there are no minimum distances, I don't need to do any distance checks. I can just place one with a certain probability. Otherwise, I have to get the first one. Or I guess I would just get the value. So I can say, so the minimum square is going to be instance minimum distances get data closest ID. Closest ID. And we have placed one of this type. Oh. Actually, I guess just this. So if the data last column is not, if we have set something, I guess. I guess this can just be closest ID is not equal to -1. Which means we were close to something. One thing that I probably could do is, like, as an optimization, I could set last column to be a higher value than it currently is. So I can say, all right, well, I've computed a minimum distance. We would have to be at least this far ahead now before we can place another one of this type. So it could be an optimization, but I'll figure that out later. Check that we're at least far enough from our closest type, or from our last closest type. Yeah, I have to multiply it together, and then I compute if we are early, let me drop this out because now I'm going to be computing it every time. I just reset this value. It's going from there. Okay. So best square is our current distance to closest, and then if this is still less than or equal to minimum square, I return. Too close. Skip. Skip instance placement. Otherwise, we've now moved at least far enough away from the last thing that we were worried about. So now we can start looking around. Which I guess this actually kind of only applies if we haven't gone back. Okay. So I'm actually gonna cut this and put it back. Here. Close. Still too close. Optimize test, only scan forward. Optimize testing when moving right on the same row. Oh, here's a question actually. I just realized this. If my row changes... Actually, if I'm only moving forward, so I can even drop down, but if I only move forward, I still know that my closest node is still like the last column that I tested. Because if it moved forward, then it would have moved forward. But if I move backwards, I have to do a full test. Okay. Let's get new closest. Four column and instance map. Stop early if it is impossible to be closer than best. So I guess that's not really true. Possibly closer than best, and further than most distant instance. Okay. So optimize test. Best option is too far. Okay, so this would be the same thing. Get the most, or get the highest distance requirements for later tests. So max, so max dist square is going to be a float. Should be 0. For inst in instance minimum distances. Yeah, I'm just computing the max distance. I don't need to know about the type at this point. Actually, I don't really care about the type, so I can actually just do values. Is it mad about something? No, okay. Actually, I guess I can just values max. Oh. Let me just do that. Yeah. The highest distance requirement for later test. Some other things possibly close and best and further than max distance. We are further than the larger value of this and max dist square. So if we're further than this away, then we know we're done. We're not going to locate anything. We're not going to see anything special at that point. Okay. So then I do this, and then on each one of these, I actually have to do a test if we are ever too close to some type. For a column and instance map, this has to be right. So this will have to actually be a loop, won't it? Yeah, it'll have to be a loop. Dang. Okay. So instance map is perhaps a bit annoying. So I have to do for inst ID in tracking. The instance ID, and then for column and instance map, If we're far away, we can stop at this point. I guess actually, this can just be recomputed, can it? I'll call this min dist square. If we are ever too close. Immediately. Cannot place here. Though I can definitely update the data closest, so I can, you know, keep track of that and its type. And maybe I track set and return immediately. If distance square, if we ever find something within our minimum distance, then we're done. We're immediately done as soon as we hit something too close. We have to continue. Data closest will be equal to this point, and data closest ID to inst ID, and we can stop. I guess I can also say data last column. Yeah, this. This was the last one that we checked, and we were too close, so we save it all and we return immediately. This is all the data, right? Last column, closest ID. Good. And you know what? I'm gonna do this. If the closest ID is -1, I'm gonna move this all up here. Because this can be a short thing to do. I guess this actually means that we have to have placed nothing. We have to have placed something that we care about, actually. And then I guess I can actually do this up here. Just move it up here entirely. For if tracking as, is that right? Tracking instance ID, good. Break. And I can just say if I actually write skip tests. If skip tests, if populate, return. Okay, so now everything actually drops out. If vertex is less than the last column, going back must get new closest. And these are getting really similar. What's the real difference here? The addition of this, and I guess this. Oh yeah, these are. And then I would just run this, I think. Okay. So if we go back, to start over. All good there. And then I need to make sure I do the same thing all the way up here. Or all the way down here at the bottom. Okay. Alrighty. Do a print there. Okay. Compute closest distance. Nearest square. We went back. We must get a new closest one. I reset everything. For instance ID and tracking, rather this is instance ID in minimum distances. Minimum distance squared would be same thing. Stop early if impossibly close to the best, and further from most distant index instance. So the closest thing that could be to us is further than our current best distance, and further than the minimum distance we need to be from anything that's closer. So we're done right there. If we are ever too close, we have to update data and then we return. Otherwise, we're not too close to something. So let's get that distance. Closest will be that, and closest ID will be this. Closest was that. Closest ID. And then nearest is that distance. Optimize testing when moving right on the same row. Check that we were far enough away from our last closest type. Still too close. So now I do this. And this should all be tabbed in. Where's our instance map though? Oh, there it is. This should be min. I gotta drop the window. It's shining on my monitor. Okay. Okay, so we check everything that we care about. We get that. Compute this. I guess I can probably do a has up here. Good optimization to make, probably. Because we truly do need this to exist for us to even try. If tracking does not have that, continue. It's in here. Good spacing. Skip columns prior to last column that they would have been tested already. So I guess I can't really do this. I can actually. I think I can do this. Can I? Because if I can't do this, then this collapses back up top. So if column is less than or equal to because here's the thought. I have one placed here, and there's a node somewhere way up front, or I guess it would have to be there's a node above it that has like some really aggressive distance check. So that was never checked, I guess. Is that the case? So I move forward. What do? I move forward. I run through here. There is no last column. Wait. Yeah, this would all just skip through it and then drop down here. This would be a nothing near this point. Oh, I guess this would be like... Where was that? Found nothing closer than something. Yeah, found nothing. Nothing closer to blank than blank. Okay. That's correct. Skip columns. I probably should get launched at this point, actually. I want to test this. I want to get this tested. Yeah, really the only thing up front is this, and I mean, this is pretty good, actually. Those two checks are still pretty good. So whatever. I wonder if I can move this up top. No, because this is a check that where if we went backwards, we have to restart. But as long as we're going forwards, I can check if I got far enough away from this one. So if this distance is still too close, do that. Then we're tracking the next closest thing. And yeah, if I hit anything, yeah, same thing. If I hit anything that's too close, I have to stop right away and save that. If we're ever too close, we are within this distance, then set our last column. This was the point, and this was the instance we tripped up on. And then we return. Furthest right points. I guess this should be favor rightmost point. Wow, he sounds sad. If we were too close, do this. Same thing here. If we were too close, do this. Favor rightmost points. Oh, and then I have to check. I have to be keeping track of the closest ID. That's... Make sure I'm updating everything correctly. Good. Okay. I think I'm there. I think I'm there. Okay, so back to the small region. Back to the small region. Minimum distances to itself. It needs to be at least 1. So this should just stop it from happening where technically that's not allowed for me to do that, so I'm not going to do that. What am I trying to do here? This is weird. Okay. Trying to assign nil to float. 788. Oh, I know why. I know exactly why. I have some of these gets, I think, where I don't have... Yeah, I don't have a default. Which I guess in this case, I like to do it if data closest ID does not equal -1. And then also still needs to be a default though. Okay. Alright. I'm actually going to go grab lunch. I'll be right back. Really quick. I'm back. They playing Minecraft without me? Yes, maybe. I don't know. Probably not. Alright. I fixed bug. I clicked populate. That's wrong. Well, that's wrong. Let me make it slightly higher. No, that's just definitely wrong. Although, is that just random chance? Yeah, it's just random chance. Odd. Unless I have to do save and then populate. Save. I'm actually confused. Because if tracking right. Okay, I get it. Still wrong. I'll bring this print back to see if this one's happening. Oh, first run, no instances. Oh, that's cool. So that would be why. Tracking somehow isn't adding anything to this, which is weird because it definitely should be. I'll bring this prints back. Like, what's going wrong here? Maybe I should. New instance map. For instance, in minimum distances, if tracking has that skip test false. Empty 0 in minimum distances, which is a dictionary of integers. Is this going to be a weird thing, like I've seen sometimes, where it just seems like the code straight up isn't updating some parts? Or what? I'll just return at this point. Oh, well, if it never does anything, then... Also, it never even printed. What? It never printed either one of these. What is happening? I've never added it. Hey, minimum distances look like they're being respected. Looks like that's being respected. I'm gonna set this to 1. It's a minimum value I can go to. And just check that it still looks the same way. Yeah, so 1 still works. Awesome. 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 What about 2? I think I have to hit save for it to update and then I click populate. Oh, no, because I'm changing the wrong thing apparently. So I'm not going to hit save and hit clear and run. Okay, good. Alright, this is awesome. Now for the big region. And I'm going to get rid of the prince because that will quickly overwhelm this thing and really slow it down if I do that. There it is, 1 meter. I'm going to say, let's be at least 4 meters away. I'll hit save. Go. Okay. Does this look regular? It's not totally regular. This also isn't even including the variation that I added. Let me just look at this again though. Oh yeah, this looks pretty regular. This doesn't look like it's there doesn't seem to be patterns. You have anime hair today? Yes. I'm trying to hide it. Cool. Alright. The minimum distance works. Let me go ahead and add this back. The wiggle effect, as I've called it. Where is it? There. He's growling. I've said his... What do you mean doxed? I've said his name before. Alright, did I clear? It's hard to see the trees here. I think I've cleared it. No tool selected. Is there... No trees. I'm gonna go ahead and get rid of these, Get rid of these ones down here. I think I've tested it enough. It's okay, Red. It's okay. Alright, populate. Now with some slight variation in between. And it really didn't add much to the time. In fact, I would say that's like not added much. Probably due to the fact that it's spawning less trees now is better. Alright, but this is definitely way too dense. So now I'm going to try to use the tool that I've made. And do a lower density. How does that look? I feel like it didn't change anything. I mean, it placed 100 fewer trees, does it not crash the game to have trees now? Well, it didn't before, but the challenge here is adding the trees at this point. Okay, so that looks fine. I think actually what I'm going to do, I'm going to delete these regions. Can I undo that? I would like to clear. Okay. Now I will delete. I'm going to draw up here. This terrain I think is pretty much nearly done in this area. So it should be a good spot to really test it. I don't really know how I will draw trees, to be honest. So I'm just gonna like restyle it or something, I don't know. That's fine. Okay. I probably kind of messed up how I'm doing my vertices here, but it's probably fine. Yeah, I should probably do things like this so I can give myself breathing room. Um, yeah, honestly, like I'm gonna be, I really don't know what I'm doing. I'm just like throwing shapes down in spots that I think might look interesting. Okay. Try that one again. Okay. I'll just leave it there. and see what this looks like. ID 1, minimum distance with itself, and I'll say 4 meters. Add a pair. Density, I'll leave it at 1. I think at this point I'm going to adjust the density for trees, so 1 looks good with trees. I also have no variation to shape, to scale, orientation, or anything like that yet. Give me the player. Let's go look at this area. Definitely would need, you know, probably some better edges when I get serious with it. But for now, I think this is enough to look at it, at least, and see what it looks like. And I guess also just to verify that collision still works. Okay, so I just walked through that. I'm not really sure why. Did I turn it off? Should be on. Oh, I think I turned this off. There we go. Collision target's on. I should probably turn off debug meshes. I don't need to see it anymore. Nice. Alright. But now how does that actually look? Definitely looks bad because there's like no variation. These are just like literally pillars. But I'm more just walking through and seeing the density. If the density looks good. This actually seems... I think what I'm going to do, I'm going to adjust it this way. I'm going to set this down to a minimum distance of 1, just so they can't be touching. But now, yeah, so now I'm going to mess with the density until 1 looks better. And I have food. I'm actually gonna go and start eating, actually. Alright. Should eat the food that I have. Can't just make it, I have to actually eat it. All right. Fast lunch. Okay. So, I'll say one thing. For the moment, I am testing with this triangle tool. I'm going to scrap it. I'm actually going to scrap it. It's not as usable as I thought it would be. And in reality, I don't care what the triangles look like. As long as the triangles can be made from any outline, essentially all I care about is the outline. I just want to click, draw points, and then triangulate the mesh. Order the points so that they're going clockwise, but then triangulate the mesh. I guess that doesn't even matter either. Because I don't need to see the interior. I just have to triangulate it and then make sure the faces all point up. Because ideally what I would do is I would say, you know what, I want this edge to be out a little bit. I could click here and drag it out, and I would add a point in the middle and drag it out that edge. So I can make the shape as complex as I want without having to deal with how it's triangulated at all. Because otherwise what I would really have to do is I have to do this, this, and then this. Yeah. Okay, I'm going to hit save. I'm going to very quickly turn off collision boxes. I got it. Okay. I turned off collision shape, but they're still there. Whatever. Actually, that really doesn't make any sense. Not sure why those are still there. What if I hit reload? They stay there, I guess. Sure. Whatever. Okay, so I'm going to tune it so the density multiplier that I apply to it is looks good for the trees. So currently I put it over or under 10. So that number needs to be higher. Needs to be higher than 10. I guess I will just jump straight to 100 and see what difference that makes. All right, interesting. So the jump to 100 did have an effect, but really not as big as I thought it would. Let's jump to 1,000. Definitely still too dense. I'm confused. I'm really confused. 10,000. Something weird is happening. That's weird. I feel like it's not doing what I think it should be doing. Okay, it's getting there. I just had to make it insanely high number. I have to make it 1,000,000, apparently. Okay, 1,000,000 was too far. Alright, 1,000,000 is too far. So, do we think 500,000? Okay, that's too far. Did I miss... Like, did I forget to hit save at some point? You know, that's too much. Okay. Now this density feels good. We'll jump it up to 2. Cool. 3. Alright. 10. So I wonder if I need to worry about if I need to do some kind of logarithmic scaling, actually. I mean, this actually seems pretty good. This does seem pretty good. Alright. Let me bring in the 4-meter distance. See what it looks like now. Okay. So that's density 1 with 4-meter minimum distance. This could not possibly be 4 meters apart, right? That's just definitely not true. I mean, it must be true, because I think I don't know how I could have done this wrong. I did something wrong. There's no way. Oh, interesting. So it doesn't even look like the same thing. I'm not even looking at the same world. What's happening? What is happening? Is it adding more when I spawn in? I must be crazy. Okay. Well, now we're definitely right. This one, like, does feel close, but I'm sure it's actually correct. So maybe 4 is just too close as well. Should jump it up to 5 meters or something. Or 4.5? I don't know. I'm sure that handles some cases. Once I get to a large enough number, small changes do matter. Cool. Though these trees also still feel maybe a little too close together. I'm not sure. Okay. I thought this was the kind of distance that I tried to fix. Yes, maybe more like 5 or 6. I'll jump it up to 6. Alright, cool. All right. Here's a question for me though. How do I stop this from happening? I guess what I would have is probably like a maximum slope and set a height offset. To like sink it into the ground, or just have the mesh have like a meter extra under the ground. A meter extra might be a little too far, but... And then from there, you can do some calculation where a certain maximum slope with the height offset and how far down the mesh extends, it would be impossible to see underneath it like this. It would always be fully into the ground. Where I retreat an extra 3 feet. Well, it's definitely math for it. I could probably figure that out. This seems like good density though. How many has it placed? That's 300 trees. Okay. Why do math if not needed? Because I want to be able to click populate and know for a fact that the settings I have, I don't have... no one's ever going to be able to find the one tree in the world that you can see underneath. I don't want that. I can do the math and prove that I will never have a tree that I can see underneath with a good margin too. Like worst case scenario, there's still like a foot into the ground. Okay, now why does it bring up the density? I think at this point, if I try this, I will get something weird happening. Where they will just become really regular. Because they place super frequently. But they're still limited by that distance. So I think I need to do some kind of... perhaps some kind of change to just the probability function. I mean, okay. These are how I want them to look. I think these are how I want them to look. So I won't worry about that. I will not worry about it. This number feels kind of crazy though. This is a bit of an insane number. All right. What? E. Two 71828. For fun. Okay. Alright, I think I'm ready to send it. Next thing is going to be adding in more settings for stuff like maximum slope. Or perhaps not even that, but like a slope range. So I could also have it be do something. I don't know what instance I would do this for. where essentially I can only place it on certain slopes. Maybe rocks? Some kind of gravel thing? I don't know. Moss? I don't know. But it may as well be in there. Okay. And I am not doing pruning yet. Let me see. All right. Let me go crazy and do a huge region over here. All right. Just a huge region. See what this looks like. Oh, and I was painting on the wrong side. Oops. Or just, I'm gonna have to go search for these vertices. Found it. There's one over here. No, I think I started with this one. Did I have one up here? No. Okay. And I'll do one more. Okay. Zero minimum distance between itself. Is it 5? Density 1. Okay. And go. It's pretty fast. Big lag. Oh no. How's the stream doing? Jesus. I'm at 80 FPS. So that's pretty cool though. That's actually pretty cool that I can run at over 60 FPS with this crazy mess I just made. All right. Clear. And add this value. Okay. Try that again. It's way slower. Wow. I mean, that's fine. I feel like I'd be okay with a region this large taking that long. Placed 10,000. Whoops. Placed 10,000 instead of 350,000. Compared to 4 seconds, this was 19 seconds. So that took a real hit tracking the distance, which is what I wanted to test. But those are trees. And really, you'd only do regions this big when you're pretty sure that you know. When you get the settings dialed in. So I would have some slope things here to stop them from spawning on the edge like that. Or on these brown parts, they shouldn't be there. But yeah, cool. 200 FPS. Looking at literally all of them. I guess more like 170, looking at literally all of them. So pretty much no impact on performance. These are all cylinders though. They don't have any alpha masking. When I get to the... I feel like I'll have to do something smarter for very distant ones. I probably would need like an LOD that is just like a flattened mesh instead of a billboard PNG, because I think that alpha mask will have a harder hit than just a mesh, of course. Alright, but cool. Yeah, cool to see that works. And I'm not doing any... Probably the biggest reason this might have been slow. I guess I have to measure it more. If the iteration through the vertices to check for tracking is what's slow, then I may find that pruning that tracking might be worth it. Because by the time you get to a region that's large enough, it's so fast. This was 350,000 and in 4 seconds. And that was so fast without any tracking that I think by the time you get big enough that you need this tracking, this time is big enough that I think it may benefit from the pruning. Okay. I will clear this and delete that. Okay. Adjust the window. I mean, yeah. For placing, I'd have to start tracking this information. Every time I place, I'd have to set use to be true. I'd have to set either left or right, depending on where it was. And then go to that other one and check its row. And if the row is above mine, if the row is above itself, I'll figure it out, because this is actually probably a little wrong. No, because how I would test it, this is right. That's right. But I mean, I think it runs fast enough that I don't 20 seconds I have no issue with. I can wait 20 seconds. I would have an issue if it was taking a minute. I think I could wait a minute. Any longer than that, then I might look at trying to optimize it. But I think this is already really good for speed. This could probably be improved. This calculation might... I mean, I don't think it takes up that much time, actually, so that's probably fine. I should probably put those clears back, though. I will go and put those back. I guess I should have tested that. The slow one, with the clear being enabled. Alright. So height, rotation, scale, colors. Of course I timed the terrain placement separately. Pruning is not happening in this. I guess what I should do is I should test putting in bushes too, and check that works. So, bushes are 1. Density, let's trim density up to 5. We need to be at least a meter away from trees. And then for ourselves, let's say at least 3 meters away from ourselves. Yeah, 3. Actually, I think I'll just put this down to 2. Raiden Halo timed out Raiden for 15 seconds. Reason idiot. Okay. Alright. You just testing that out? Bushes. That felt kind of slow though. A half second. Sure. What? Did it break? What was that? What? That's weird. Oh, clearing didn't work. Let me go fix that. Right click on Firefox. One of the options now is ask an AI chatbot. Yeah. A clear region, I think, just clears out zeros. Yeah. So I'll build a set of this. I think this array should be pretty small. So I'll just make an array of int. Overwatch? No. Oh, my counter. I forgot about the counter. I am now 2 days over my thing. So. Distraction, distraction, distraction. What? What does that mean? I don't understand that. So if not IDs has inst ID, continue. Okay. Now I hit clear. It'll go away. Awesome. Cool. This is getting annoying though. That debug thing is getting really annoying. I want to reload the project. Why the orb back? I guess I forgot. Hit save. That's annoying. I think I also want to make it so that wiggle will incorporate nearby vertices. Especially for low distances. You know, maybe I don't care. Maybe I don't care. Maybe I don't care. Okay. Oh, and this was actually incorrect. What? Between itself. Did I mess that up? I think it did. Populate. So that can't be right. This should have not placed there. At least I don't think so. Oh, where'd they go? Oh, they disappear when I do that. So this one would have placed at this index. This one should have placed here, and this one placed here. So that's definitely not at least 2 units away from each other. Unless I, like, didn't save the thing correctly. Okay, it's happened again. These two were placed at this vertice and this vertice. They should have not been placed here because that was too close. So why is that happening? And why does it seem like it's only those ones? I can't find another... Oh, I found another close pair. So this one placed here, this one placed here. Or... what? Here? This is like a pair of 3 that are way too close. How did these place? How could these have placed? This is weird. I don't like this. I don't like that I don't know how that's happening. It could not be... I can only move it, I think, yeah, 35 centimeters away. There's no way that if they're actually being placed 2 units apart. So this must be a mistake. There must be a mistake in my distance check somehow. And for some reason that it collapsed a lot. That was supposed to populate instance. So for instance, in minimum distances, if we don't have it, we're done. We do have it. We get that distance. We square it. It's at least 1 is the weird thing. This is at least 1. Perhaps what's happening is... if I'm far enough away that I don't need to check this one anymore, and I've gone past myself, the larger these two values break. So that one can't be it. If distance squared is less than or equal to minimum distance squared, yeah, that's correct. Set that in return. Return. So we won't place it here. Down here. You know what? Let me see if I can reproduce it. It seems really rare, but it does happen sometimes. Yeah, these two are definitely way too close. So let me see if I can reproduce it with a very small region. Over here in the positive coordinates. Cool. And I'm also glad to see that wireframe works there. Okay, so I'm going to just go and save this as something. Pop settings, I guess. Forest with bushes. Okay. So that's saved. I come back here. I will load. Forest with bushes. Populate. Okay, so here's my idea for this. I'm going to turn on all of the printing that I have, and I'm just going to keep running this until I get two that spawn too close together. And then I will see what the possible issue was. Okay, we're too close. Do print. Too close. Return. Too close to last instance of that. Still close to last that. And then on blank, that was too close. Okay. And then the row print as well. It's a really nice thing to have. And then I'm going to get rid of the movement on these. I'm going to get rid of the change in position on these. So it's very clear. Okay, should be ready. Awesome, I got one right away. String formatting, arrow not all arguments converted during string formatting. What? Nothing closer to blank than what? Well, whatever. Whatever. This should have happened pretty much right away. So row 4, no instances, no instances. When I place one, it should do that. What is happening? What? Oh, first instance. Oh. Okay, but I still had it happen right away, so I'm gonna keep this. Found 0, which was too close for the tree. Distance squared 0. What? That's not possible. Distance squared 0? That's weird. Why did that happen? Found blank, that was too close. The minimum distance squared came out to be 0. How does that happen? What? That doesn't make sense. That doesn't make sense. Zero is not possible. Oh, you know what? Okay, so technically I'm allowed to place instances on the same point. I'm just not allowed to place the same instance on this. I mean, I should be allowed to place the same instance on the same point. If I set it up so that happens, so that it can happen, then that's my mistake. So what happened was, the bush has to be at least 1 unit from the tree, and it just placed a tree. So that's why I said it was 0. Then we get the found instance 0 that was too close. Which is 1, we can't place anything there. We got here. Nothing closer than that. Still too close for the tree. I guess it's 4, right? Squared 4. We get here. On the next placement. New instance, blank. Still too close to that one for the tree, I think. Yeah. That'd be 36. And then it just didn't do the distance check correctly. Why did it start at row 4, by the way? Oh, I guess 1, 2, 3, 4. Yeah, okay. New instance. New instance. Yeah, so why did this fail? Because it should have logged this here and seen it. Instead, we're too close. It should have done that. It didn't do that. So I guess I'll just print tracking. I'll print out tracking. I'll print out tracking at the end of adding one. Also print out print V. Okay, I don't know why I'm clicking up there. See if I get it to happen again. It didn't happen that time. Didn't happen that time. It happened twice. Awesome. So this will be row 5 that this happens on. I think what I'll do is I'll just make it so this LOD thing, I think it's probably on here. Or I guess not like that. Same thing as this one, actually. The max value. Just, yeah, the max. Alright, I'll be right back. Dog is barking. I'm back. Okay, so why did this happen? How did this happen? So I'm looking at row 5. So I found a 0 that was too close, a tree closest. No. This dog keeps like getting in my trash can. He's like sitting next to me, so I pet him, and then he sticks his head in the trash can. Rhett, go lay down. No. No, go lay down. Go lay down. Go lay down. No. Come here. Go lay down. Go lay down. You stay. Lay down. You're not behaving. Okay, so we placed one at column 5, row 4. Then I placed one here, so I'll go until I get the 1, so a 7 and a 5. And it says, for the tree, still too close to 0. We're still on this point at this. Yeah, we should be here. Still too close to 0. And then it says nothing closer to 8.5 than 7.5. I see it. So it's actually skipped itself? How? It needs to set itself as the closest thing, I think. Is that what's happening? It seems like it can place them right next to each other, but then if we go one further, then it can't do that. Then it actually will like start respecting it. But when we are on the 1, so yeah, nothing closer. So here is what happened. This test up here basically failed. This test failed. So data closest and closest ID need to be set whenever I place something, which I'm not doing. I need to be setting that. So data closest and closest ID. It says itself as the closest one. I guess the problem with this is that there's a problem. Essentially what has to happen is this might need to be tracked per ID. For everyone that I'm tracking, I need to track the closest one to me, because I can't override it like this. This is not correct. So if I find something that's too close, I need to get so far away from it. But here's where this is kind of breaking down. If I have 3 things, say I have a tree. I don't know, let's say I have a mega tree. for anything to appear, it has to be at least 50 meters from the mega tree. So I place the mega tree. I track that, or whatever. I go to the next one. I need to start looking for a new closest object. Actually, what I need to do is every time I place one, right? Okay, so here's what I'm getting at. I place this mega tree, and I get far enough away from it on that row. I start a new row, and now I'm not close to it anymore, so I'm not even checking it. So as I'm going through, I'm still placing and placing and placing. I get within 50 meters of the mega tree, but at this point, at this point, I'm not even looking that far away. I'm just looking to see. Is it? Wait. Let me check what this is doing. For each one at minimum distance, I run through there. Right. So data probably needs to be tracked per thing, right? So this way I can loop through data, or I guess I would grab data for this instance ID so that I can drop the closest ID, and now I'm just checking the last column that I read for this one. Maybe it's a bit too much, I don't know. I do have a return though, but I set it there before I return. Okay. Data does have to be per thing like that. So I go and get data set up. It's actually just gonna be empty. Yeah. It actually is just going to be empty. But I will set it to just an empty dictionary. Actually, I guess what I do is I would do... yeah. Can't do that. That's, there's something else down below that does that. Or blank in minimum distances. So this will be the last comment I checked and the closest one of that type. And then I say I guess I'm actually setting it anyway because, yeah. Okay. So now that that is set, for inside E and minimum distances, going through each one of these, if I find one and then data has to actually be changed, I think, to inst data. What? I hit Control Z instead by accident. So if we're ever too close to something, we can just save it right there and we can just keep going. We don't need to check anything else. Still. At the end of each of these loops, though, I guess, yeah, I only need to really check. Oh, here's the thing. I'm only supposed to be doing it for myself. So, if it is myself, this is for density. So, this is not the case. Continue. Okay. The IDs go away. If closest, if closest, if this is myself, then I have the closest one, essentially. If closest does not equal is this best square? So best square to set the int to max. Closest to blank was blank. Okay. And last column. Yeah, last column is just kind of set right away. can kind of drop that. But I do want last column to be unset here while I do this test. And then I set it here. Is this correct? Inst data. This would be this should be done for each one of these. So actually, yeah, this should be done for each one of these. Now I see what's going on here. So yeah, this is different. So don't need that. And this should come in. Oh, and this is that last column isn't checked in here, so I can do this. Or instance data last column for each of these. Right, and so if it's greater than this one, I guess I have to do a check here. Let me do this up here. That's like a boolean at the top. Is self. Otherwise, I only care if I'm far enough away that I don't care about it. Because density only affects you when you're looking at yourself. If is self. It's actually this. Do all that together. Nothing found near that. Closest to blank was blank. Is self. Minimum distance. Instance data last column. I guess I can actually move this up here. Because I still want to write it, that we check this column. But then I don't need to do this other stuff if we can't track. Because then I could say, yes, I checked this column, there was just nothing ever placed there. So then we can start working forward and reducing how much we check. So I'll do the same thing down here. Yeah, though last column. If I do this, instance map, I need the instance data. And I guess I can even save it. I can save this last column. Let me do it here. Okay, cool. Instance data. Do the same thing again where I find that so I can track them. Make sure I update all the right spots. This can just be less than last column. And I want this is self. This is correct. Is self instance map. Yep. I don't care about that. Closest is inside of here. Right, it has to be inside of there. So I'll move it all in here. Point is outside. Whatever. Point doesn't need to be outside, does it? Yeah, point doesn't need to exist outside of this. Whatever, though. It's inside of its own thing already, so I'll leave it. Closest needs to be there. That all can be like that. I kind of want to make the minimum distance separated. Not tracking. Update that and continue. Otherwise, stash the last column and then update it. So I don't have to update it later. And then if we are the self, we're doing both of these. Otherwise, we're only stopping if we are greater than this minimum distance squared. So if we hit something that needs to be tracked, I don't need to do that. Don't need that. Just print closest and or update closest, and that's it. So closest. Here I need to say if not self. Continue because this is supposed to be rest is only for density. Not updating that. This would be tabbed in. ID goes away. And I think the test is this. Max, and it's not the same as our current closest. Okay. Then put instance, we'll be doing this, and I'll simply set this should all be made for me. So data okay. Let me look up here at data. Because it seems like I'm only tracking last column and closest now, so I want to verify that that's all I have. Last data, or last column and closest, yep. Data closest, this is wrong, so check that we are at least far enough from well, our closest instances. So best square. It could be possible that this is nothing. If there's nothing to track, we skip. If we have something we may want to track. I'm not reading closest here, but I am reading it here. I will be reading through instance data here. So I think what I have to do is I have to go through each one of these, and then I check if I have one set. So if start with int to max. Vertex distance squared to inst data, but I guess I need to check. So if it is equal to that, I don't check it. Otherwise, I will check. And then I have to do this. So minimum square is going to be instances get this, get, and these should only be here in data if I am checking it, or itself if I have a density, right? Which I always have a density, actually, so. If inst ID in minimum distance yeah. Or instance ID is equal to instance setting ID. Oh wait, this is 4. If it doesn't have that one, status set the same thing. Ensure itself is present for density logic. Which should be impossible. Oh, this would be the case if it's not enabled. Yeah. Or it's -1. If his data doesn't have its own ID, edit. Man. Okay. So down here, I'm just going to read through this. This should be making sense. Self. If it's itself, we check that we are further than our best. Or if the max distance, if the best one that we can get here is further than our current best distance, and also greater than this value. Technically is what this means with the max there. Greater than both, and we can stop. Otherwise, it's not a self, we're just checking that we are greater than this value. Then we can stop. Then we do the real test. If we're too close, we save that as our closest point, and we jump out. We don't need to check anything else. Should be done at that point. Yeah, basically the idea is if we actually even get to that point of checking the column, so we can say, yes, we thoroughly checked this one. We found something. If we are ourselves, do the distance stuff. Save our closest point. And save the distance. If we get through all of it, I guess, technically I can say at this point, the dog is ready to eat. I guess I should probably end stream. Hang on, buddy. So this will clear that. So next time I would get down here, I would skip the test. And the only time we read closest is right here. This is a read to check if we're still too close to it. Once we're far enough away, we will clear it. Otherwise, we are never reading it ever. We're only reading it for that one, for this one case. He's gonna try the other side of me. You're silly, Red. What are you doing? If we are still too close, then this would be a return. If we're the self, and I say if this is less than or equal to that, I'm just going to copy this. Closest, though. Guess I should probably have a check for the closest thing. Do I need the closest thing? No, I shouldn't be finding one, actually. I don't know why I thought that. I shouldn't even be finding one. Else it is this case. This instance is no longer too close. And I guess I'm not updating. Yeah, what do I do here? I think I just had it returned before, right? I don't know if I need to save the vertex that I set. What did I have written before? I just said return, still too close. I guess the idea behind this one is that I haven't actually really checked this column yet. So my last column is still behind me. I just know that right now I'm still too close. I haven't done a full check. So I guess it makes sense. I haven't done a full check of this column, so I just say still too close in return. If we're ourselves, and actually just if we're ourselves, just do that. It is this distance. And then we would of course start by looking for a closer one than that. Which this would actually be if okay. That line goes away. And then I guess move this up. Still close to that point. Drop all that. Check that we're at least far enough away from all our closest instances. This will need like a really good thorough review by myself later. This is a lot of code, and I'm losing it a little bit. And I didn't even notice this problem either, but it was seems like a pretty simple fix. It's just, there's so much to modify for this. If tracking does not have the instance ID, we set our column, we continue. Otherwise, stash the column, update it, and now we're looking for a closest thing of this type. Check if we're ourselves. Get that instance map. The minimum distance that we need to be for the current ID. And then if our column is less than our last column that we checked, we can just skip it. Stop early if we're ourselves, and the closest that this point can be is still further than our best distance and the minimum distance we need to be, then we are done. Otherwise, if it's further than our minimum distance, then we're done. As well. Not as well, but just if we're not ourselves, then this is why we would be done. Get our distance. If we're too close, update our closest point. And then I do a print and return. If we are not checking ourselves, we will continue. The rest is only for density. Favor rightmost point when equal distance. Okay. And then update our best distance. If ourselves and we got something that was close and it's not the same thing, new closest is that. Nearest. So nearest may need to be set in this case, right here. Because I don't think I actually set it. If we are not too close to the last point, then we need to search. So we'll find our closest point. Okay, dude, you're okay. I'm trying to wrap it up. Minimize that, I think. So this seems a bit kind of wrong. We need to set this. I need to set this up here too. This has to be set up here too. That needs to be set there too. And unless we find something closer, then that will take over. Okay. Everything seems correct now, I think. Ooh, bunch of problems. Okay. So I guess I just missed one, line 748. I did. Oh, weird. Oh, interesting. This has to be flipped around a lot, actually. I guess this is actually meant to be checking ourselves. So if the instance we're trying to place were backwards, then we need to do a full update. That's the idea behind this. Data, get. Okay, that's the idea behind that one. All right. Try that again. Okay, so apparently closest ID. Yeah, see, this is like the issue with it. I'm making these mistakes. So this should be inst ID. Do a find for closest ID. Okay, good. DAO. Okay, so weirdly it like failed to place anything that time. Yeah, so that bush should be placing more than one. So there's a problem with that. The bush is we're only placing one each. Okay, well, I kind of got there. I'll have to read the code myself and really review it. Okay. Just gonna look through it. Yeah. I'm gonna send what I have and then do a read through on my own to figure out where I went wrong here. Because it was working, and when I added this in, now it seems like it can only place one instance of any type. So it's obviously a mistake. This dog. Rip. Stop it. Stop. I think, yeah, this region data. Yeah, okay. Should be all of it. I think the settings were... What? Wait, what? That was weird. I thought I was like looking at... Damn, why is the world staged? I remember why. In case I like messed up. Okay. Oh, that's fine. And then, yeah, those were just some changes there. And then I'm not adding anything else. Okay. Regions now populate with density and minimum distances. Bug was adding, or it was fixing a density slash distance bug, and now it's can only spawn we'll fix later. Okay, that's gonna be it for today. Because yeah, I'm just gonna have to sit down and read through that code to figure out what's wrong with it. Probably when I'm a bit less tired. Okay, thanks for watching. I'll be back tomorrow. Hopefully tomorrow's the last day that I'm working on this tool, and then I can finally start putting getting actual foliage in. That looks good. So, yeah. Thanks for watching. Be back tomorrow. Goodbye.